Welcome to Quiet Universe, where the stars may not always shine and the planets don't always have suns. Imagine a world adrift, completely alone in the cold, dark stretches of space. Planets that float free, untethered to any star. In today's journey, we're diving into the strange and mysterious world of rogue planets. These nomads of the cosmos are unlike anything we usually think of when imagining planets. No warmth from a sun, no fixed orbit, just a silent drift through the galaxy. From the enigmatic CFB-DSIR 2149-0403 to the curious OGLE 2005 BLG 390. These are the rebels of space, defying the gravitational norms we take for granted. Buckle in as we explore 30 of the most intriguing rogue planets ever discovered, each with its own story of cosmic isolation. Let's start by seeing what makes these wandering worlds so fascinating. Now, I have to warn you, these planets come with some pretty weird names. Like CFB-DSIR 2149-0403 or SIMP J01365663 plus 0933473. Names that sound like someone just mashed their keyboard. But don't worry, I'll guide you through this. So, get ready, because we're about to dive into the vast, dark sea of space where these rogue planets roam free. Buckle up. It's going to be a strange ride. CFB-DSIR 2149-0403 is a peculiar object that defies many traditional categories in astronomy, and what makes it particularly fascinating is the mystery that surrounds its existence and nature. It's classified as either a rogue planet or a brown dwarf. These two classifications are intriguing on their own, but what's truly mind-boggling is the fact that this object exists alone, wandering the vastness of space without a parent star. Imagine, for a moment, the nature of a rogue planet, something that was possibly formed in a solar system like our own and then ejected, flung out by some chaotic cosmic event. Now, this planet, or substellar object, floats through the universe untethered, no longer basking in the light of a sun. The idea of such isolation is captivating in a very human way. The sheer loneliness of it feels almost poetic. There's something haunting about the image of a planet or brown dwarf drifting alone in the cold expanse of interstellar space, with no nearby light or heat to guide it, no solar system to call home. The ambiguity of whether CFB-DSIR 2149-0403 is a planet or a brown dwarf adds to the allure. Brown dwarfs are sometimes called failed stars because they didn't gather enough mass to ignite nuclear fusion in their cores like regular stars do. If it's a brown dwarf, then it's a reminder of the fragile boundary between success and failure in the cosmos. This object sits on the cusp of stellar ignition, but never quite got there. It's like a cosmic, almost eternally trapped in an in-between state, neither fully star nor fully planet. If it's a planet, it's fascinating to imagine the violent, gravitational upheavals that must have led to its ejection from whatever system it once belonged to. What's even more striking is the idea that CFB-DSIR 2149-0403 may be part of a moving group of stars known as the AB Doradus Moving Group, though this association remains unconfirmed. This group of stars is thought to be relatively young in cosmic terms, about 100 to 200 million years old. If the object is indeed part of this group, then it's incredibly young on the scale of the universe. It hasn't had the eons of time to evolve like the planets and stars we observe in older systems. This youth adds another layer to the mystery. An untethered object so young might still hold clues to its violent origins. But there's more. Because CFB-DSIR 2149-0403 is alone and doesn't have the illuminating effects of a nearby star, scientists have to work with limited information to study its composition and characteristics. Its isolation presents a challenge, but also an opportunity. Since it isn't drowned out by the light of a star, its thermal emissions can be studied in greater detail. Using infrared observations, scientists have found that it likely has a temperature of around 400 degrees Celsius to 500 degrees Celsius. It's mind-bending to consider that something so cold, by stellar standards, can still exist in such a raw and ancient state, floating indefinitely. Adding a human perspective to the story of CFB-DSIR 2149-0403, there's something about its solitary existence that evokes a sense of wonder about our place in the universe. We, too, are a part of this vast, lonely cosmos, searching for meaning, trying to understand the forces that shaped us. Just as astronomers peer into the darkness to study rogue planets and failed stars, we, in our own lives, seek understanding in the unknown and the unseen. The story of CFB-DSIR 2149-0403 is, in some ways, a story of the universe itself. Chaotic, unpredictable, filled with almosts and maybes, yet still bound by the quiet beauty of existence, even in isolation. What makes it even more intriguing is that these rogue planets, like CFB-DSIR 2149-0403, might not be all that rare. There could be billions of such objects, wandering alone, and each one represents an entirely different history. Each one a remnant of something larger, perhaps a glimpse into the forces that have shaped the cosmos itself. The knowledge that objects like CFB-DSIR 2149-0403 exist in the dark, infinite void only adds to the wonder of what might be out there, beyond our reach and understanding, shaping the silent, distant realms of space. SIMP J01365663 plus 0933473 is one of those objects in the universe that reminds us how little we actually know about the vastness of space and the strange things lurking within it. It's a massive object, right on the edge of what we can classify, a brown dwarf, but one with characteristics that make it even more extraordinary. What immediately sets it apart is its intense magnetic field, something so powerful that it defies what we typically expect from objects of its kind. Normally, magnetic fields this strong are associated with pulsars or other highly energetic celestial bodies. Yet here is this lone object, drifting in space, with a magnetic force that astonishes scientists. What makes SIMP J01365663 plus 0933473 even more intriguing is that it appears to exhibit auroras. Yes, like the northern lights we see on Earth, but on a scale that's hard to even comprehend. For a brown dwarf to have such strong auroral activity is bizarre because auroras typically require some kind of interaction with a star's solar wind. And yet SIMP J01365663 plus 0933473 isn't orbiting any star. It's a rogue, floating alone in the cosmos. It forces us to rethink our assumptions about how auroras can form. This phenomenon is perhaps driven by some kind of internal dynamo, a process that, on Earth, drives our planet's own magnetic field but at a scale and power far beyond anything we can imagine. This object also sits in an uncomfortable space between definitions. Like many brown dwarfs, it's not quite a planet, but it's not really a star either. SIMP J01365663 plus 0933473 has about 12 times the mass of Jupiter, meaning it's just below the threshold where deuterium fusion could have occurred, a process that distinguishes brown dwarfs from massive gas giants like Jupiter. It's almost as if this object wanted to be a star, but just didn't quite have enough mass to ignite into one. The fact that it is so massive yet so close to being a planet challenges our rigid ways of classifying celestial bodies. It sits on the blurry boundary between failed star and giant planet, reminding us that nature often doesn't conform to the categories we try to force upon it. What's mind-bending is that it's relatively close to us, only about 20 light-years away. In the grand scale of the universe, that's practically in our cosmic backyard. Yet for so long, we didn't even know it existed. This proximity raises questions about what else might be out there, still undiscovered, lurking in the interstellar void, hidden by the darkness but close enough to feel almost within reach. The discovery of SIMP J01365663 plus 0933473 was part of a broader realization that these kinds of objects, rogue planets and brown dwarfs, may be far more common than we once thought. For every star we can see in the night sky, there could be countless other objects wandering alone, too faint to be easily detected but just as real and just as significant. Adding a human dimension to this, it's hard not to draw a comparison to our own search for understanding in the universe. We often try to fit things into neat boxes, to categorize, to understand by labeling. But then we come across objects like SIMP J01365663 plus 0933473 that stubbornly refuse to fit, and we're left confronting the limitations of our knowledge. This is a very human experience, trying to grasp something that resists easy explanation. It mirrors our own lives in some ways. We encounter things that don't fit into our expectations, that surprise us, and we have to reframe our understanding of the world. just like astronomers had to rethink what they knew about magnetic fields, auroras, and planetary boundaries because of this object. Even more, the idea of a massive body like SIMP J01365663 plus 0933473 floating alone in space feels almost lonely, like a cosmic wanderer. Without the warmth or the gravitational pull of a star to guide it, it exists in isolation, but not in silence. Its magnetic field and auroras tell a story of internal processes we still don't fully understand. It's as if the object is communicating in its own way, through the language of physics and magnetism, sending out signals that we are only just beginning to interpret. There's a beauty in that, in the idea that even something so far removed from our everyday experience still has a life of its own, still interacts with the universe in ways we're only just discovering. The sheer scale and power of SIMP J01365663 plus 0933473 make us feel small, but it also sparks curiosity. It makes us wonder about the countless mysteries the universe still holds, the strange objects and phenomena that challenge what we think we know. And in that curiosity, there's a reflection of our own desire to explore, to understand, to make sense of the cosmos even when the cosmos doesn't always make sense to us. WIZIA J11472 4.10-204021.3 is an object that, at first glance, seems like it should be straightforward to categorize, but like many things in the universe, it defies simple definitions. This is another brown dwarf, an object too small to sustain nuclear fusion like a star, yet too large to be a planet. But what sets WIZIA J11472 4.10-204021.3 apart isn't just what it is. It's how it behaves and how it challenges our understanding of these in-between objects. One of the most fascinating things about it is its extraordinarily cool temperature. For a brown dwarf, WIZIA J11472 4.10-204021.3 has a temperature that can dip to just a few hundred degrees Celsius. To put that in perspective, this means that it's barely hotter than a kitchen oven, yet it's still massive, with enough gravitational pull to shape its own little world of mystery. What makes this even more mind-boggling is how difficult it is to detect something like WIZIA J11472 4.10-204021.3. It's so faint that without the specialized infrared telescopes used to find it, it would be entirely invisible to us, blending into the dark background of space. This faintness comes from its low temperature, and it raises the fascinating possibility that there are many more objects like it, hidden in the darkness, waiting to be discovered. We only found this one because of the precision and persistence of astronomers using data from the WISE mission, an all-sky infrared survey. Imagine how much of the universe remains hidden, just out of sight, simply because we don't yet have the tools or technology to detect it. There's also something incredibly intriguing about the idea that WIZIA J11472 4.10-204021.3 could be one of the oldest objects in our local galactic neighborhood. Brown dwarfs like this one don't change much over billions of years. Without the nuclear fusion that powers stars, they cool slowly and quietly, just drifting through space. It's possible that WIZIA J11472 4.10-204021.3 has been around for an unfathomably long time, a relic of the early days of star formation in our galaxy. To think that it could have witnessed the birth and death of stars, planets, and entire solar systems, without being a part of any of it, gives it a kind of timeless, ancient presence that's hard to wrap our minds around. It's like looking at a cosmic ghost, something that has simply persisted, unchanged, for most of the history of the Milky Way. Adding to the wonder is the fact that, despite being alone in space, WIZIA J11472 4.10-204021.3 could still be linked to other objects. Some researchers think it might have once been part of a binary system, a pair of objects gravitationally bound to each other. If true, then something catastrophic must have happened to rip them apart. This kind of cosmic violence isn't something we typically associate with such cold, quiet objects, but the universe has a way of surprising us. The idea that WIZIA J11472 4.10-204021.3 might have once had a companion only to be cast adrift, forever wandering alone, adds a layer of poignancy to its existence. From a human perspective, there's something hauntingly beautiful about that. an object born to float through the cosmos alone, keeping its secrets close, barely detectable, but carrying the scars of a history we can only speculate about. It's as if WIZIA J11472.4.10-204021.3 is a traveler with a story to tell, if only we had the means to fully understand it. Its quiet, nearly invisible nature mirrors the human desire to find meaning in the unknown, to reach out into the darkness and try to grasp what lies beyond our immediate perception. In many ways, it forces us to consider how limited our view of the universe really is. Even with our best telescopes and instruments, we're only seeing a tiny fraction of what's out there. For every WIZIA J11472.4.10-204021.3 we discover, there could be countless more objects that elude us. Mysterious, cold, and ancient, quietly drifting through the fabric of space-time. The discovery of these objects opens our eyes to the possibility that the universe is filled with things we've never even imagined, slowly rewriting what we think we know about the cosmic landscape. In this sense, WIZIA J11472.4.10-204021.3 isn't just an object. It's a reminder of the vast, uncharted territories of the universe, and of our own ongoing journey to understand it. PSO J318.5-22 is one of those objects that feels like it was plucked straight from the pages of science fiction, yet it's very real, and even more, it challenges the way we understand planets and stars. It's often described as a rogue planet, meaning it doesn't orbit a star like the planets in our solar system do. Instead, it's adrift, traveling through space on its own, without the gravitational anchor of a sun to guide it. This alone is a mind-boggling concept. Something as massive as a planet, just floating freely in the vastness of the galaxy, untethered and isolated. But PSO J318.5-22 is no ordinary rogue planet. What sets it apart is that it's not just wandering through space. It belongs to a group of stars known as the Beta Pictoris Moving Group. This makes it part of a young, dynamic family of stars that formed around the same time, about 12 million years ago. A blink of an eye in cosmic terms. The fact that PSO J318.5-22 is so young means it's still cooling down and radiating heat from its formation. That heat makes it detectable in infrared, even though it's not reflecting any light from a nearby star like most planets do. It's as if it's still glowing from the energy of its birth, giving us a glimpse into a phase of planetary development we rarely get to observe. What's really strange and fascinating about PSO J318.5-22 is its nature as a rogue object. We know how planets form around stars, gradually coalescing from the disk of gas and dust that surrounds a newborn sun. But how do planets end up alone, wandering through space? Did PSO J318.5-22 form in isolation? Or was it once part of a solar system before being violently ejected by some gravitational catastrophe? These are the kinds of questions that keep astronomers up at night because, in many ways, objects like PSO J318.5-22 are cosmic enigmas. They hold the clues to the chaotic processes that shape planetary systems, but they leave us with more questions than answers. In terms of mass, PSO J318.5-22 is about 8 times heavier than Jupiter, placing it right on the borderline between what we consider a large planet and what could be a failed star or brown dwarf. It's in this nebulous space where classifications blur, and it's a reminder that the universe doesn't neatly divide itself into categories for our convenience. The fact that we're not even sure whether to call it a planet or a substellar object only adds to its mystery. It's like the universe itself is teasing us, revealing just enough to keep us guessing but withholding the full picture. From a human perspective, there's something deeply haunting about the existence of rogue planets like PSO J318.5-22. Here is a world that, if it had a stable orbit around a star, might have developed in ways we could predict. It might have moons, a stable climate, and maybe even the potential for life. Though the conditions on PSO J318.5-22 itself would likely be inhospitable. But because it's wandering alone, it exists in a kind of cosmic exile. This brings up an interesting parallel to our own lives. How much of who we are is shaped by the environment we're placed in? Just as a planet's orbit determines its climate and potential for life, we are shaped by the gravitational pulls of family, society, and circumstance. Take those away, and you're left adrift, like PSO J318.5-22, still full of potential, but with a trajectory entirely unknown. There's also the sheer loneliness of it, a world without a sun. PSOJ 318.5-22 drifts through space, cold and dark, without the light that typically defines a planet's existence. In a way, it forces us to rethink the very nature of what a planet can be. Planets, in our minds, are always tied to stars, caught in the delicate dance of gravity. But PSOJ 318.5-22 exists outside that familiar framework, and that's what makes it so intriguing. It's not just breaking the rules of what we think planets should be. It's redefining them altogether. In many ways, PSOJ 318.5-22 is a testament to the fact that the universe is far stranger and more complex than our models and definitions can ever fully encompass. The discovery of rogue planets like PSOJ 318.5-22 hints that these objects might not be as rare as we once thought. In fact, there could be countless rogue planets drifting through our galaxy, invisible to us because they don't have the light of a star to reveal their presence. They are the dark matter of the planetary world, unseen but potentially shaping the structure of the universe in ways we don't yet understand. PSOJ 318.5-22 is a reminder that there's so much we still don't know about how planets form, how they survive, and how they might thrive or suffer in the cold isolation of deep space. Thinking about PSOJ 318.5-22 leads to a kind of existential reflection. What does it mean for a planet to be truly alone, cut off from the warmth and energy of a star? And what does that say about the fragile conditions that make life possible here on Earth? It's a stark reminder of how delicate and rare our situation is. While PSOJ 318.5-22 is fascinating from a scientific perspective, it's also a cosmic symbol of isolation, a world that exists without the fundamental relationships we associate with planetary systems. It challenges not only our scientific understanding but also our philosophical grasp of what it means to belong, to be connected to something larger. In that sense, PSOJ 318.5-22 is more than just a planetary oddity. It's a reflection of the deeper mysteries of existence itself. 2MASS J 11193254 1137466 is one of those celestial objects that pulls you into a deeper understanding of the strange diversity the universe holds, especially when it comes to things that don't fit neatly into any established category. At first, it was believed to be a solitary object, a brown dwarf, like so many others, too small to ignite into a full-fledged star, but too large to be considered a planet. But what makes it mind-bending is that, on closer inspection, it turns out not to be just one object but potentially part of a binary system. There's evidence suggesting it may be one half of a system consisting of two sub-brown dwarfs, or very low-mass objects, orbiting each other. The sheer idea of two failed stars in a binary dance, both too small to burn like stars, yet massive enough to exist in tandem, is fascinating. What really grabs your attention about 2MASS J 11193254 1137466 is its incredible youth, cosmically speaking. This object, or pair of objects, belongs to a nearby young association called the TW Hydra Association, which is about 10 million years old. In terms of the universe's timeline, 10 million years is nothing. A brief flicker. This means 2MASS J 11193254 1137466 is still cooling down from its formation, still radiating heat from that primordial moment when it first coalesced. You're essentially looking at something that, while it might seem ancient from a human perspective, is in its cosmic infancy, offering a rare glimpse into what planets and substellar objects look like when they're just beginning their long life cycles. But there's an odd twist. Despite its young age, 2MASS J 11193254 1137466 seems to be free-floating, not bound to any particular star. This immediately raises the intriguing question of its origins. Was it once part of a larger planetary system, only to be cast out by some gravitational disruption? Or did it form on its own, in the same chaotic regions where stars are born, but without gathering enough mass to become a star? The possibility that it's a free-floating planetary mass object gives it this aura of loneliness, of being adrift in space without a stellar home, which almost makes it feel like it's defying the rules of what we think planets or stars should be. Its mass also sits right in that ambiguous region, about 4 to 8 times the mass of Jupiter, which places it on the fine line between a massive planet and a brown dwarf. This uncertainty keeps it suspended in that liminal space between definitions, forcing us to confront how artificial some of our astronomical categories can be. We like to box things in, label them as stars, planets, or brown dwarfs, but the universe doesn't operate with the same need for clarity. It's messy, and objects like 2-mass J1-119-3254-1-137-466 remind us of that complexity. There's something deeply human about our attraction to this kind of cosmic ambiguity. We love trying to understand things, to categorize, to make sense of the world. And when we encounter something that doesn't fit neatly into our frameworks, it forces us to think differently. 2-mass J1-119-3254-1-137-466, with its uncertain mass, its possible dual nature, and its status as a free-floating object, is a perfect example of this. It's a reminder that the universe often surprises us, that there are things out there that challenge our perceptions and force us to accept that we don't have all the answers. What also makes 2-mass J1-119-3254-1-137-466 special is how it might offer clues about planetary formation itself. If it is a free-floating planet or pair of objects, studying it could help astronomers better understand how common these types of objects are. If there are many free-floating planets like this one, it could reshape our understanding of how planetary systems evolve and, more importantly, how often planets might get ejected from their systems and wander the galaxy on their own. The possibility of millions of planets out there, orphaned, and wandering through the darkness without stars to orbit, adds a haunting element to the story of our universe. It shows how dynamic and violent the birth of solar systems can be. An entirely different kind of life from the peaceful orbits we observe in our own solar system. There's also a strangely poetic aspect to thinking about 2-mass J1-119-3254-1-137-466 as part of a binary system. Two objects traveling together through space, neither quite a star nor quite a planet, yet linked in this gravitational dance. It evokes a kind of cosmic companionship in the midst of the overwhelming emptiness of space, a reminder that even in the coldest and darkest corners of the universe, relationships, however strange or fleeting, exist. These two objects, if indeed they are bound to each other, are like cosmic travelers, locked in their mutual orbit, navigating the vastness of the galaxy without a guiding star, relying only on their own shared mass to stay connected. In the end, 2-mass J1-119-3254-1-137-466 isn't just a distant, cold object floating in space. It's a symbol of the universe's unpredictability and its capacity to surprise us. It forces us to grapple with questions about how things form, how they evolve, and how little we really know about the vast array of celestial objects that populate our galaxy. And in that, there's a reflection of our own curiosity and desire to understand the world around us, to reach out into the unknown and make sense of it, even when the answers are elusive and the questions themselves keep changing. OGLE 2016 BLG 1928 is an extraordinary discovery that pushes the boundaries of what we think is possible in planetary systems. What's fascinating is that this planet, detected through a technique called gravitational microlensing, seems to be a rogue planet, much like others that have been discovered, but with a key difference. It's smaller than Earth, making it potentially the smallest rogue planet ever detected. The sheer idea that something so tiny, on the scale of planets, is out there wandering through space without a star to call home is mind-boggling. This detection was a needle in a cosmic haystack situation, relying on the subtle bending of light from a background star as the planet passed in front of it, creating the briefest flicker in the sky. What really gets under your skin about OGLE 2016 BLG 1928 is the sheer isolation of it. Planets usually form in the dust and gas disks around stars, gathering matter until they reach their final size. But OGLE 2016 BLG 1928 appears to be out there alone, without the warmth or energy of a star to orbit. The fact that such a small object, only slightly larger than Mars, could be ejected from its home system or perhaps even formed independently in the vastness of space forces us to question what we know about planetary formation. It suggests that the process is not always as tidy as we once thought, where planets form in neat, orderly systems. Instead, The early stages of star and planet formation might be far more chaotic, with rogue planets like this one being flung out into the galaxy during their chaotic early days. This discovery also touches on the profound loneliness of the cosmos. Rogue planets like OGLE 2016, BLG 1928 don't have a sun to orbit, no star to offer light or heat. They drift through the cold and empty expanses of space, utterly disconnected from the celestial systems we're familiar with. It's hard not to project a sense of solitude onto this object, a small, cold planet wandering the galaxy, invisible unless it happens to pass in front of a distant star, only briefly revealing itself through that flicker of light. There's a kind of melancholic beauty in that, a reminder of how vast and lonely space can be, and how even the smallest objects can hold within them the secrets of creation. The implications of finding such a small rogue planet are profound. For years, astronomers have theorized that there could be more rogue planets in the galaxy than stars, but evidence for small ones like OGLE 2016, BLG 1928 has been sparse. The fact that we were able to detect this one, using microlensing, suggests that there could be countless more out there, completely invisible to us except under the rarest circumstances. If these tiny, starless planets are common, it could fundamentally change how we think about planetary systems. Instead of being exceptions, rogue planets like OGLE 2016, BLG 1928 might actually be the rule, wandering the galaxy in the billions, if not trillions, unseen and alone. On a human level, this discovery is a powerful reminder of how limited our perception of the universe is. Even with our advanced technology, we're still barely scratching the surface of what's out there. To think that an entire class of planetary objects, perhaps the most numerous type in the galaxy, could have been hiding in plain sight is humbling. It's as if the universe is telling us again and again that we don't have all the answers, that there are more mysteries out there than we can even begin to comprehend. There's also something poetic in the way OGLE 2016, BLG 1928 was discovered. Microlensing is a technique that relies on chance alignments, where the gravitational field of one object temporarily magnifies the light from another, far behind it. It's fleeting, a brief moment where everything lines up perfectly, and for just a few hours or days, we can glimpse something otherwise invisible. It's a reminder of how fragile and momentary our discoveries can be, how so much in the universe happens outside of our ability to observe it. It's like catching the smallest possible wave in the vast ocean of space, and for that brief moment, we get to see something extraordinary. And in that, there's a reflection of human experience, too. We go about our lives, often focused on the immediate, the visible, but occasionally, something fleeting happens. A chance encounter, a rare moment, and it gives us a glimpse of a much larger reality. OGLE 2016, BLG 1928 is a cosmic version of that experience, something we would have never seen if everything hadn't aligned just right. It speaks to the nature of discovery itself, how often it's not just about what we're looking for, but about being open to the unexpected when it appears, even if only for a brief moment. 2 Mass J044144489 plus 2301513 is an object that challenges the boundaries between stars, planets, and something in between. It exists in that strange territory where mass and classification get blurry. What makes this particular object so fascinating is that it's considered a brown dwarf, a failed star that never gathered enough mass to ignite fusion in its core like our Sun. Yet it exists within a system alongside a smaller companion, which might be a planetary mass object or an even smaller brown dwarf. This unusual pairing of objects that aren't quite stars but still generate heat makes it feel like nature's cosmic experiment in testing the limits of planetary and stellar formation. The true intrigue lies in its mass and how young it is. 2 Mass J044144489 plus 2301513 is part of a very young star-forming region called Taurus, only about a few million years old. It's essentially a baby in astronomical terms, and it's still glowing from the energy of its formation. At around 20 times the mass of Jupiter, it sits at the boundary between what we might call a massive planet or a brown dwarf, with its companion estimated to be even smaller, potentially only a few times the mass of Jupiter. This difference in scale makes it mind-bending because it stretches the definitions of what we think a system should be. If we found something like this in isolation, we might classify its smaller companion as a planet. But here, It's orbiting another object that isn't quite a star, leaving us questioning whether it's right to think of this as a planetary system at all or as a very low-mass stellar binary. What draws you in further is the sense of developmental chaos that must have occurred during its formation. In traditional star systems, stars form from collapsing clouds of gas and dust, while planets form in the protoplanetary disk that surrounds a young star. But with brown dwarfs like 2-mass J04414489 plus 2301513, this process might have been radically different. Did it form like a star, or did it form more like a massive planet that never quite made it into full stardom? There's a certain beauty in that chaos. The way these objects blur the lines between what we thought we understood about how celestial bodies evolve. Thinking about 2-mass J04414489 plus 2301513 also brings up some deep philosophical questions. We like to think of planets and stars as distinct objects, each with clear roles in the cosmic order, but this object throws all of that into question. It shows that the universe doesn't care about our neat categories, that it's perfectly capable of producing things that don't fit into our boxes. It forces you to consider that perhaps most of the cosmos is made up of things that defy easy classification. There's something inherently human in our need to label things, to give them names and roles, but this object reminds us that the universe is far more complex and doesn't conform to our expectations. Another fascinating aspect of 2-mass J04414489 plus 2301513 is how it might change our understanding of planetary systems in general. If objects like this exist, then perhaps they are more common than we think. Maybe there are countless other systems out there, made up of brown dwarfs with companions that we might otherwise classify as planets. And if that's true, it could mean that planetary formation is much more diverse than we ever imagined, stretching far beyond the star-centered systems we're used to. It hints at a galaxy filled with roguelike objects, binary pairs, and systems that look nothing like our solar system. The idea that this object has a companion, orbiting it like a planet, but not really fitting the mold of what we think a planet should be, creates a haunting sense of isolation. In the vast expanse of space, even this small, failed star has found something to orbit with. It's a reminder that even in the loneliest reaches of the galaxy, objects are interacting with one another, forming relationships that are as complex as anything we find here on Earth. There's something oddly comforting in that, even as it challenges the way we've categorized and understood celestial systems. 2-mass J04414489 plus 2301513 embodies the unexpected nature of the universe. It's a place where definitions are stretched, where things that shouldn't exist together somehow do. This object, and others like it, make you realize that the cosmos is much more than stars and planets. It's a vast, unpredictable system filled with surprises, where the rules as we know them are constantly being rewritten. It forces us to think not just in terms of what we know, but to embrace the mystery of what we have yet to understand. MOA 2011 BLG 262 is an object that challenges everything we thought we knew about planets, moons, and the complexity of celestial bodies. It was detected using gravitational microlensing, a technique that relies on the chance alignment of objects in space, where one object passes in front of another, magnifying the light of a distant star. What makes MOA 2011 BLG 262 particularly intriguing is that it might be a rogue planet, or even a planet-sized object that could be a moon, and we're not quite sure which. It's in this strange liminal space between those two definitions, leaving astronomers to speculate about what exactly it is and how it came to be. One of the most mind-boggling aspects of this object is that it could be the first detected instance of a rogue planet with its own moon. Or it might be a planet-sized object orbiting a brown dwarf or another object. The ambiguity makes it especially compelling. If it's a planet with a moon, that's a wild notion because rogue planets are typically thought of as lonely wanderers, ejected from their star systems to drift through the galaxy. The idea that such a planet might still retain a moon, even as it floats in the cold emptiness of interstellar space, forces us to rethink what we know about how planets and moons form and how they behave after being ejected from their original systems. What draws you into MOA 2011 BLG 262 is the sense of cosmic isolation mixed with companionship. Even if this is a rogue planet with a moon, it's still drifting in the vastness of space, without a star to orbit. It's a world that, in all likelihood, experiences perpetual night, with no sun to provide warmth or light, just the endless cold and darkness of the galaxy. And yet, it might have a companion, a moon that orbits it in a gravitational bond. It's an image that evokes a kind of lonely resilience, two objects tethered together, wandering through space with no guiding star, relying only on each other. The implications of discovering something like MOA 2011 BLG 262 are profound. If this is truly a rogue planet with a moon, it raises the question of how common such systems might be. Could there be other rogue planets, cast out from their parent stars, still holding on to moons? It also suggests that the process of planetary ejection might not be as clean as we once thought. Instead of a planet being flung out of its system alone, it might bring with it other bodies, moons, debris, or even smaller planets. This opens up a whole new way of thinking about the aftermath of planetary formation and system disruptions. What's also remarkable is how this discovery was made. Gravitational microlensing events are rare and require everything to align perfectly. For a brief moment, MOA 2011 BLG 262 passed in front of a distant star, and its gravity bent the light just enough for us to detect it. That fleeting moment of alignment, where everything had to be in exactly the right place, underscores how much of the universe is invisible to us most of the time. We live in a universe full of objects we'll never see, unless by sheer chance we catch them in a moment like this. It's a reminder of how limited our perspective is and how much there is still to discover. MOA 2011 BLG 262 also forces us to confront the fragility of our definitions. We like to think of planets as objects that orbit stars, and moons as objects that orbit planets. But here, those lines blur. Is this a planet with a moon? Or is it something else entirely? An entirely new kind of object that defies our conventional categories? It's not just a scientific puzzle. It's a reminder that the universe operates on a scale of complexity that we're only beginning to understand. It's humbling to think that even our best efforts to classify the cosmos can sometimes fall short when faced with the strangeness of what's out there. There's also something haunting about the potential loneliness of this system. If MOA 2011 BLG 262 is a rogue planet, it's a world without a sun, drifting through space at unimaginable speeds. And yet, the possibility that it carries a moon with it suggests a kind of companionship even in the vast isolation of the universe. It's a small reminder that even in the coldest, most remote regions of space, there are bonds, gravitational ties that keep objects connected, even as they drift far from where they began. Ultimately, MOA 2011 BLG 262 is a glimpse into the unknown. It's an object that sits at the edge of what we can detect and understand, challenging our perceptions of planets, moons, and the structure of the cosmos. It's a symbol of the complexity and unpredictability of the universe, where even something as seemingly simple as a planet or moon can defy our expectations. It's a reminder that, despite all we've learned, the universe still holds secrets, waiting for us to discover them in fleeting moments of cosmic alignment. OGLE 2012 BLG 1323 is one of those celestial objects that leaves you questioning the boundaries of how planetary systems are formed and how little we still understand about the vast intricacies of the universe. It was discovered through gravitational microlensing, a method that captures brief flashes of light bent by the gravity of an unseen object, giving us a fleeting look into its existence. What makes this particular object fascinating is that it sits on the edge of what we would classify as a planet and something more massive. The ambiguity surrounding its nature is what draws you in, forcing you to confront the limits of human knowledge and how our understanding is still patchy when it comes to the far reaches of space. The fact that OGLE 2012 BLG 1323 might represent a planet orbiting a distant star in a system so faint we can barely detect it reminds us how fragile and fleeting our observations really are. It's an event that occurs once, a brief bending of light that gives us a hint of something bigger, but after that, it's gone, hidden once again in the cosmic dark. That very elusiveness is almost poetic. There are likely billions of objects like it scattered throughout the galaxy, most of them invisible to us, their existence known only through these brief flashes, suggesting that the universe is teeming with worlds we may never truly see. The sheer scale of this discovery touches on something fundamentally human, the idea of searching for something you can barely perceive. OGLE 2012 BLG 1323 could be a planet similar in mass to Neptune, orbiting its distant star at a vast distance, and the conditions on it are utterly unknown. It's this silence, this unknown, that makes the discovery feel so haunting. If it is a planet, we have no idea what its surface is like, what its atmosphere holds, or if it even has one. Could it be a gas giant like our Neptune, or something entirely different, far beyond our frame of reference? The answers are locked away, beyond our reach, existing only in a fleeting moment when light bends in just the right way to reveal it. Another mind-boggling aspect of OGLE 2012 BLG 1323 is the possibility that its planetary system, if that's what it is, might have been stable for billions of years. This stability, this endurance in a universe that is often chaotic, makes you wonder what kinds of cosmic events have shaped its past. Has it always been alone out there, orbiting its star at a distance so vast that it experiences temperatures and conditions we can't even imagine? The age of the system could span eons, well before human civilization even began, making our entire history seem like a blip in the cosmic timeline. There's something humbling in thinking about that, about how a planet like OGLE 2012 BLG 1323 has been drifting silently through the galaxy while entire species have risen and fallen on Earth. But what's truly staggering is the thought that OGLE 2012 BLG 1323 could be one of many planets orbiting a distant, faint star, forming a system that mirrors what we see closer to home but with a twist. The possibility that such systems exist, far beyond the reach of our telescopes, detectable only through these rare microlensing events, opens up a whole new way of thinking about the structure of the galaxy. It suggests that planetary systems are not confined to the bright, easy-to-spot stars, but might be far more common around faint, hidden stars, or even rogue planets. The universe might be littered with planetary systems that we will never observe directly, making the discovery of OGLE 2012 BLG 1323 a tantalizing glimpse into this unseen world. Beyond the science, there's an emotional component to this kind of discovery. OGLE 2012 BLG 1323 feels like a reminder of the vastness of space and how, even in the emptiest stretches, there's so much happening beyond our perception. It makes you think about our place in the cosmos, not as the center of things, but as part of a much larger, more complex network of planets and stars. The thought that this planet has likely been there for billions of years, unobserved and undisturbed, yet it finally revealed itself to us for just a moment, makes you reflect on the nature of discovery. It's fleeting, like much of life, where we only get glimpses of something larger before it disappears again into the vast unknown. In many ways, OGLE 2012 BLG 1323 is a testament to human curiosity. Even though we might never visit it, and it may remain a distant, unknowable object, the fact that we're able to detect its presence at all speaks to the incredible ingenuity of our technology and our methods. It's a reminder that, no matter how small or distant something might be, we have the tools to see it, even if just for a moment. That fleeting connection between us and an unseen world across the galaxy feels almost magical, a brief moment of clarity in an otherwise obscured universe. And it leaves you wondering, what else is out there, waiting to be discovered, just beyond the limits of what we can see? WISE J085510.83-071442.5 is one of those objects in space that feels like an enigma, a cold, distant mystery that leaves you rethinking everything you assumed about what exists beyond the solar system. It's one of the coldest known brown dwarfs, a failed star that couldn't quite ignite, drifting quietly through space. Brown dwarfs are strange to begin with, but this one stands out for how astonishingly cold it is, about as cold as the Earth's North Pole in some seasons. When you think of stars or anything remotely star-like, you imagine heat, radiation, energy pouring out into space. But WISE J085510.83-071442.5 is so cold that, in some senses, it's more like a planet than a star. This alone blurs the line between what we consider stars, planets, or something in between. It sits just over 7 light-years away from us, making it one of the closest objects outside our solar system. Yet, despite its proximity, it was only discovered in 2014 by NASA's Wide Field Infrared Survey Explorer, WISE. And that's because objects like this emit so little light and are so faint that they're almost invisible. It's hard to wrap your head around the fact that something so close, cosmically speaking, could remain hidden from us for so long. It's a humbling reminder of how vast and dark space is, how even in our own cosmic neighborhood, there are things lurking in the shadows that we've yet to find. What really pulls you into the story of WiseJ085510.83-071442.5 is its temperature, around -50 to -100 degrees Fahrenheit. Think about that for a moment. This isn't a planet, which we expect to be cold in the absence of a star. It's a brown dwarf, an object that formed similarly to a star but didn't have enough mass to sustain nuclear fusion. It's mind-bending because, up until this discovery, the coldest brown dwarfs we knew of were still far warmer, more akin to the heat of a warm summer day on Earth. But here's this object, a failed star, wandering the galaxy at temperatures you'd expect from ice worlds, closer to the cold extremes of planetary bodies like Neptune than to any star. Another captivating detail about WiseJ085510.83-071442.5 is how it defies easy classification. It's not a planet, even though its mass is estimated to be between 3 and 10 times that of Jupiter. And it's not a star, because it lacks the necessary nuclear reactions that keep stars burning. It exists in a kind of limbo, too big to be a planet, too cold and small to be a proper star. There's something oddly compelling about that. It doesn't fit our neat boxes, and that reflects the universe's tendency to defy our expectations. It's a reminder that space is filled with strange in-betweens, objects that don't conform to what we think we know. WiseJ085510.83-071442.5 is also a fascinating target for future exploration because it represents what could be a whole population of cold brown dwarfs lurking out there, invisible except for the faint infrared glow they emit. If there are more objects like this, scattered across the galaxy, it changes how we think about the distribution of mass in the universe. How many other failed stars are floating unnoticed, too dim to be seen by traditional means, yet close enough to be practically on our doorstep? The fact that we found this one suggests that there might be a vast number of similar objects hidden in plain sight, waiting to be discovered. Beyond its physical characteristics, there's something deeply evocative about the journey of WiseJ085510.83-071442.5 through space. It's a solitary object moving across the backdrop of the galaxy with no known companions, no star to orbit. It's traveling at a significant speed, about 200,000 miles per hour relative to the Sun. This sense of motion, this lonely drift through the interstellar void, evokes a kind of cosmic loneliness. It's not part of a system. It's not tethered to any gravitational dance with other bodies. It's just there, moving silently, its faint infrared glow betraying its presence to the few instruments sensitive enough to detect it. What's even more intriguing is the potential for what we could learn from it. As we develop more advanced observational techniques, especially those that look into the infrared spectrum, WiseJ085510.83-071442.5 could offer a window into a whole class of objects that are right on the border of stars and planets. It could help refine our understanding of how these objects form, how they evolve, and what happens when the delicate balance between star and planet tips one way or the other. Every detail we learn from it could reshape our understanding of the different kinds of bodies populating the galaxy, many of which likely don't fit into our current definitions. The discovery of WiseJ085510.83-071442.5 is also a story of patience, persistence, and the power of technology. It shows how, even though we've mapped so much of the visible universe, there are still whole realms we can't see, hiding in the infrared, the subtlest flickers of light. It's a reminder that discovery doesn't always come in a blaze of glory. Sometimes it's just a quiet signal from the darkness, something barely noticeable, waiting for us to pay attention. And when we do, the universe suddenly feels a little bit bigger and a lot stranger than we imagined. OGLE 2017 BLG 0560 is a fascinating celestial object that captured the attention of astronomers due to the unique method by which it was discovered: gravitational microlensing. This technique involves detecting distant celestial objects, like exoplanets or stars, when their gravitational field bends the light from an even more distant background star. The name OGLE refers to the optical gravitational lensing experiment, a long-running project aimed at detecting these subtle yet powerful distortions in the cosmos. What makes OGLE 2017 BLG 0560 remarkable is not just its discovery, but the way it challenges our understanding of planetary formation and existence. Imagine for a moment how small and insignificant Earth feels when you consider that light, bending across unfathomable distances, allows us to detect a planet so far away that its light takes thousands, if not millions, of years to reach us. OGLE 2017 BLG 0560 could host a planetary system so alien to our own that we can barely grasp its full nature. While we know of its existence through microlensing, it's almost like seeing a shadow of something we can't yet fully perceive or explore. This object likely harbors a planet orbiting a distant star, one so far away that we can only guess at its size, its composition, and what it might feel like to stand on its surface. These kinds of detections raise the tantalizing question: if we are discovering planets through these indirect methods, just how many are out there, waiting to be found? What kinds of environments could these worlds possess? Could OGLE 2017 BLG 0560's planet have extreme weather, turbulent atmospheres, or even conditions that are right for life? The human element in this discovery is the awe of realizing that we are part of something much larger than our immediate surroundings. It's an instance of cosmic detective work, where researchers painstakingly piece together clues from light curves, with the hopes of better understanding not only how planets form in different regions of the galaxy, but also whether there are planets similar to ours hidden in these faraway systems. When you think about it, OGLE 2017 BLG 0560 represents a bridge between what we know and what we don't. It's a beacon for future generations, suggesting that space, time, and life might have possibilities beyond our current grasp. The discovery highlights the limits of human knowledge, yet also the boundless potential for new breakthroughs, as if every newly found planet extends the horizon of human curiosity just a little bit further. This object leaves us with as many questions as answers, pushing us to imagine not only what lies beyond the edges of our solar system, but what could lie beyond the fringes of our understanding of reality itself. KOI 6204, like many exoplanetary candidates discovered by the Kepler mission, presents a window into the broader mysteries of our universe, hinting at the variety and strangeness of planetary systems that exist beyond our solar neighborhood. The label KOI, which stands for Kepler Object of Interest, already suggests that this star system might hold a planet, or perhaps more than one, caught in the delicate dance of orbiting its host star. While not all KOIs turn out to be confirmed planets, KOI 6204 has captured interest for a reason. It exhibits characteristics that make astronomers believe a world, perhaps one like our own, orbits within its gravitational grasp. The mind-bending thing about KOI 6204 is that its potential planet exists in a space so far removed from Earth that imagining its reality feels more like science fiction than a simple fact of discovery. It's as if we are staring across a vast ocean, knowing there is land on the other side, but unable to see the details. The distances involved are incomprehensible. Hundreds, maybe thousands of light years separate us from this system. Yet we detect it through the minuscule dimming of its star as something passes in front of it. For that to even be possible, for us to find this needle in the galactic haystack, requires a perfect alignment, a cosmic coincidence, that the planet transits in such a way that we can observe it from our tiny corner of the universe. One of the more intriguing possibilities surrounding KOI 6204 is the type of planet it might host. Could it be a gas giant, orbiting at a distance far from its star, wrapped in swirling clouds of volatile gases and churning storms? Or perhaps a rocky planet with an atmosphere, a surface, and a dynamic system that could spark the idea of life? Either scenario pushes our imagination to the limits. What would it be like to stand on that surface, to feel its gravity pull on your body, to see the alien sun in its sky? If there is life there, what forms could it take? Life on Earth is bound to the chemistry of our planet, but KOI 6204's potential planet might offer something completely different. The discovery of KOI 6204 and other exoplanets also leads us to reflect on what it means to be human in this vast and largely unknown universe. We stand on the shore of understanding, sending out signals, telescopes, and missions, trying to catch glimpses of distant worlds that might help us answer fundamental questions about life and existence. But for now, KOI 6204, and it's like remain tantalizingly just out of reach, teasing us with their silence, reminding us that the universe is filled with countless mysteries yet to be solved. It challenges our sense of scale and significance, making us both humble and bold as we push the boundaries of what we know. Each of these discoveries is a step toward understanding not only these distant worlds but our own place in the cosmic puzzle. OGLE 2014 BLG 1722 is another example of how the universe continues to surprise and challenge our expectations. Discovered through the same gravitational microlensing method that reveals objects hidden in the far reaches of space, it is a reminder that even in the quietest, most distant corners of the cosmos, there is something significant happening. When light from a background star is bent and magnified by an unseen object in the foreground, we are offered a brief glimpse into the invisible, into places where our telescopes can't directly peer. And in the case of OGLE 2014 BLG 1722, that fleeting distortion hinted at something extraordinary. The sheer idea of gravitational microlensing is already difficult to fully grasp. Imagine the vast emptiness of space, where objects are so distant from each other that light can travel uninterrupted for billions of years. Then, something as subtle as a star or planet passing in front of a light source bends that light just enough for us to detect it. OGLE 2014 BLG 1722 is one of these objects, whose existence was revealed not by direct observation, but through this cosmic trick of light. It's like looking at shadows to learn about the shape of something you cannot see. One of the most mind-bending aspects of this discovery is how it demonstrates that planets can form in places and ways we wouldn't expect. In some cases, the planets detected through microlensing don't follow the familiar rules that govern our solar system. OGLE 2014 BLG 1722 may host a planet orbiting its star at a distance so vast that it challenges our models of planetary formation. These worlds could be cold, lonely places, drifting far from the warmth of their parent stars. Yet they still exist, proving that the cosmos is far more diverse and chaotic than we once thought. But what is truly awe-inspiring is the realization of just how much we don't know. Every new discovery, like OGLE 2014 BLG 1722, doesn't just add to our knowledge of planets. It adds to our ignorance, showing us the vast scale of what we have yet to understand. How many more worlds like this are out there? What kinds of environments do they possess? Could life somehow adapt to these extreme conditions, or are they entirely barren? In reflecting on the human element of this discovery, it's impossible not to feel small in the grand scheme of things. OGLE 2014 BLG 1722 lies at a distance we cannot even comprehend, in a galaxy full of stars and planets we may never visit. Yet, even as we face this cosmic enormity, there's something deeply human about trying to understand it. It's as though, through every new discovery, we are pushing back against the darkness, expanding the edges of our knowledge bit by bit, trying to make sense of a universe that is vast beyond imagination. We are explorers at heart, and even when we can't physically travel to these distant worlds, we find ways to reach them through the light they bend and the stories they tell. KMT 2019 BLG 2073 is one of those discoveries that subtly pulls back the curtain on the cosmic mechanics happening far from our gaze. Detected through the gravitational microlensing method, the event itself lasted only a brief moment, a flicker of time in which we caught sight of a distant star's light bending around another unseen object. That object, it turns out, could be something like a planet, possibly a rogue one, wandering through space without a host star. The concept alone feels like it stretches the limits of what we typically imagine when thinking about planets. A world adrift, untethered, in the cold and silent void of interstellar space. Its fate sealed by the chaotic forces of its formation, or by some cosmic event that ripped it from its original orbit. What's especially fascinating is that planets like KMT 2019 BLG 2073 defy our most ingrained assumptions. We are used to thinking of planets as part of a system, orbiting a sun, drawing energy and light from their parent star. But here we have the possibility of a planet existing entirely in the dark, without the familiar rhythm of day and night, without the warmth that we take for granted as essential for life. It raises questions about just how diverse the universe is, how many of these rogue planets might be wandering through the galaxy undetected, And what kinds of bizarre environments might exist on their surfaces? Could a rogue planet retain enough heat from its core to support some form of life? Could it carry the remnants of an ancient, star-bound past, now left to drift indefinitely? KMT 2019 BLG 2073 challenges us to think beyond the boundaries of solar systems and the gravitational bonds that usually define a planet's life cycle. These kinds of discoveries make the universe seem less like a place of order and more like a chaotic, ever-shifting landscape where planets are not guaranteed stability. It invites us to reconsider the fragility of planetary systems, reminding us that cosmic forces are far more powerful than the fragile structures we might build to make sense of them. Even in this vast unknown, where rogue planets might drift for billions of years, there's something deeply human in our need to find and understand them. The more we learn about objects like KMT 2019 BLG 2073, the more it feels like the universe is an endless puzzle, one that we are compelled to solve, piece by piece, even if the whole picture will never fully come into view. The way this discovery shakes up our understanding of planetary systems also taps into a larger question. Just how common are rogue planets? Are they rare exceptions or abundant wanderers? These questions don't just expand our scientific curiosity. They also challenge our imagination. How would life survive on such a world, if at all? Is it possible that rogue planets, instead of being desolate, might have unique forms of resilience? We may never get all the answers, but every new observation, like KMT 2019 BLG 2073, brings us one step closer to understanding the broader cosmic dance. Looking back at what could enhance this response, first, it might benefit from more in-depth scientific detail about microlensing and planetary formation. Second, I could explore more vivid speculative scenarios about life on a rogue planet. Should I try to add any of these angles? MOA 2011 BLG 191 is another of those distant, almost ghostly worlds detected not by direct observation, but through the intricate bending of light by gravity. It's a reminder of how the universe hides its secrets, allowing us only the smallest of glimpses. This particular discovery, made through the MOA, microlensing observations in astrophysics collaboration, captures the haunting reality that there are entire planets, and perhaps entire planetary systems, that we may never directly see. We only know they are there because they momentarily alter the path of light, revealing their presence like shadows cast by something unseen. What's so mind-boggling about MOA 2011 BLG 191 is the method through which we've detected it, almost like an accident of cosmic alignment. The light from a more distant star is bent and magnified as the gravitational field of the planet and its host star passes between us and that distant light source. This technique allows us to peer into areas of space that would otherwise be inaccessible. When you stop to think about it, the precision and timing required for this to happen are staggering. A distant star and a planet, hundreds of light years away, just so happen to align in such a way that we, on Earth, notice the flicker. It's as if the universe is allowing us a quick peek at something mysterious and profound, only for that moment to slip away again. MOA 2011 BLG 191 is especially intriguing because it hints at planets and environments far removed from anything we've seen in our own solar system. These planets could be orbiting stars far older or far younger than our Sun, or in parts of the galaxy where planetary formation follows rules that we don't yet fully understand. The distance between the planet and its star, the size of the planet, and its composition are all just vague impressions we piece together from the data. It forces us to confront the possibility that we only know a fraction of what might be out there. Imagine a world where the atmosphere is a swirl of unknown gases, where the surface might be an ocean of molten rock or frozen nitrogen, depending on its distance from its star. The human element here comes from the realization that discoveries like MOA 2011 BLG 191 show us the limits of our understanding, but also the boundless potential of it. We are using tools and methods that push the boundaries of what we can know, yet these tools also remind us how much remains hidden. For every planet like MOA 2011 BLG 191 that we discover, there are likely thousands more that we have no way of detecting yet. It's both humbling and exhilarating to think about the unseen universe all around us, teeming with planets that may never reveal themselves in our lifetimes. These discoveries speak to the relentless curiosity of the human spirit, the drive to explore and understand, even when the answers are incomplete or fleeting. MOA 2011, BLG 191, like many of these gravitational microlensing discoveries, leaves us wondering what it would be like to explore these distant worlds. What kinds of extreme weather, alien landscapes, or strange physics might dominate on a planet like this? It could be a place of extremes, cold beyond imagining or bathed in the radiation of a nearby star. Or perhaps it's a rogue planet, wandering through space, barely clinging to its own heat. The vast range of possibilities is dizzying. These worlds, detected in such an indirect way, challenge us to think not just about planets as we know them, but about the diversity of planetary systems scattered across the universe. Each discovery stretches our imagination and our understanding, reminding us that, while we might be confined to Earth, the universe is anything but limited. OGLE 2012 BLG 0724 is one of those distant planets that serves as a silent testament to the vastness of the cosmos. A reminder that the universe is filled with mysteries we can only catch glimpses of through delicate methods like gravitational microlensing. The discovery itself is fleeting, almost as though we were eavesdropping on a cosmic secret. The planet, hidden behind its star, passed in front of a distant light source just long enough for its gravity to warp the light. And in that brief moment, we learn that something, a planet, exists far beyond our immediate reach. What's truly staggering about OGLE 2012 BLG 0724 is the distance involved. The star and its planet could be thousands of light years away, far beyond the regions we know well, out in the galaxy's less traveled neighborhoods. It's a world we can barely imagine, yet we have proof of its existence through a faint distortion of light. This idea of discovering worlds we may never visit, planets we'll never directly observe, is both humbling and exhilarating. It pulls us into a larger narrative about how the universe operates on scales of time and space that dwarf our everyday experience. These distant planets are just as real as Earth, yet they remain unreachable, existing in a cosmic solitude that's hard to fully grasp. In this case, OGLE 2012 BLG 0724 may be part of a planetary system that formed under very different conditions from our own. The method of discovery, microlensing, doesn't reveal much about the planet's surface or atmosphere, but it does give us a sense of how diverse planetary formation can be. The planet could be orbiting a star that's cooler or hotter than our sun, or it could be in a system where planets interact in ways we don't yet understand. The mass of the planet is another fascinating aspect. Many of the planets discovered through microlensing tend to be massive, potentially gas giants, or planets with thick atmospheres that defy easy classification. But what really hits home is the thought of how many planets like OGLE 2012 BLG 0724 are out there, quietly drifting through space, their light too faint or too far for us to notice. This planet is just one of countless others waiting to be discovered. And for everyone we find, thousands remain hidden in the cosmic distance. It forces us to confront the idea that the universe is teeming with worlds, most of which we will never encounter, but all of which add to the grand, chaotic structure of existence. There's something deeply human about our desire to understand these distant planets. Despite the impossibility of ever visiting OGLE 2012 BLG 0724, the act of discovery itself is enough to make us wonder. What would it be like to stand on that planet, to feel its gravity pull you down, to look up at an alien sky where the constellations bear no resemblance to our own? What if, on the surface of that planet, some form of life, completely different from anything on Earth, has found a way to survive? Or, conversely, what if it's a cold, desolate place, devoid of atmosphere or warmth, where nothing but rock and ice remain? These questions are what make discoveries like OGLE 2012 BLG 0724 so captivating. Even when we don't have all the answers, just knowing that these places exist expands our understanding of what's possible in the universe. Each new planet we discover is a step toward realizing how little we truly know about the cosmos. And yet, in that ignorance, there's endless potential for future exploration and discovery. KMT 2020 BLG 0414 is yet another reminder that the universe is full of surprises, constantly revealing worlds that challenge our understanding of planetary systems. Detected through gravitational microlensing, this planet was discovered not because we directly observed it, but because its gravity briefly distorted the light from a distant star behind it. This method feels like catching a reflection in a mirror. Indirect, fleeting, yet unmistakable. For that one moment, KMT 2020 BLG 0414 made its presence known, whispering to us from an unimaginable distance away. What makes this discovery so intriguing is the sheer complexity of the microlensing method, which allows us to detect planets far beyond the reach of other techniques. The fact that a planet so far away can reveal itself to us through such a subtle bending of light feels like a quiet marvel of cosmic alignment. KMT 2020 BLG 0414 exists somewhere in the galaxy, orbiting its star, but what kind of world it is remains largely a mystery. The planet could be massive, perhaps a gas giant like Jupiter, or something smaller and more elusive. It might orbit its star in a distant, cold orbit, far from the heat and light we take for granted. The possibilities seem endless, and yet we only get this one glimpse, forcing us to piece together its story from limited data. What's even more mind-boggling about KMT 2020 BLG 0414 is the context in which it exists. It's one of countless planets drifting through space, many of which we will never detect. It could belong to a system that formed under conditions vastly different from our own, where planetary orbits are chaotic and the gravitational forces shaping them are more complex than we can easily model. The planet itself might have a history we can only guess at. Perhaps it formed close to its star and then migrated outward. Or maybe it's always been in a distant, isolated orbit. These unknowns stir the imagination because they force us to confront the limits of what we can know. There's something about this mystery that makes the universe feel vast beyond comprehension, as if every new discovery only opens up more questions. The human element in all of this comes from our innate drive to explore, to seek out the unknown even when the answers seem impossibly far away. Discovering KMT 2020 BLG 0414 is like finding a message in a bottle, cast into the cosmic ocean eons ago. And though we may never visit this world, the simple act of knowing it exists is enough to fill us with wonder. It forces us to imagine what life might be like in such a distant system, where the rules we're familiar with, such as proximity to a star or the makeup of a planet's atmosphere, may not apply. Could life somehow adapt to conditions we would find uninhabitable? Or is this planet a frozen, desolate place, far removed from the warmth and light of its star, drifting in the cold of space? KMT 2020 BLG 0414, like many planets discovered through microlensing, is a testament to the idea that the universe is infinitely more diverse and strange than we can imagine. Each new planet we discover changes the way we think about our place in the cosmos. It forces us to reckon with the idea that Earth is not the center of anything, but rather one of many planets scattered across an incomprehensibly large galaxy. This understanding might feel humbling, but it also carries a sense of awe. Each discovery is a reminder of how little we know and how much there is still to explore. Every new planet, like KMT 2020 BLG 0414, is a window into the unknown, inviting us to keep looking further, to keep wondering what else is out there, just beyond the reach of our instruments. MOA 2012 BLG 505 is another world that forces us to reconsider what we know about planets and their formation, a distant, almost unreachable point in the cosmos. Its discovery, like so many others using the gravitational microlensing technique, comes not from direct observation, but from a slight bending of light, a distortion so subtle that without the precise alignment of distant stars and planetary bodies, we would never have known it existed. For a moment, this planet revealed itself as its gravity affected the light from a background star, creating a brief but telling signal that hinted at its presence. What makes MOA 2012 BLG 505 truly fascinating is how little we can directly know about it, and yet how much it opens up in terms of imagination and possibility. This planet might be massive, perhaps even comparable to Jupiter, but in a part of the galaxy that is much colder, farther away from its host star, or even a rogue planet drifting without a star to orbit. It could be surrounded by moons or debris, an entire miniature system hidden from our view, only detectable through this single, momentary flicker of light. Each microlensing event is like a cosmic fingerprint, unique and brief, telling us just enough to realize how much more there is to understand. The distances involved with MOA 2012 BLG 505 are staggering. It's located thousands of light years away from us, in a part of the galaxy we'll never directly explore in our lifetimes. Yet, here we are, detecting it from Earth, a planet that is incomprehensibly far from it. It's a reminder of just how interconnected the universe can be, even when the objects we study are separated by such vast distances. This realization alone is enough to make one pause and think about the sheer scale of the universe, how it operates on levels so far removed from our everyday experience that we can hardly grasp it. What's particularly mind-boggling is the idea of planets like MOA 2012, BLG 505 potentially existing in environments completely different from anything we know. If it's far from its star, it could be a frozen giant, its atmosphere composed of gases that would be unthinkable on Earth. Or, if it's a rogue planet, it could be wandering through the dark, completely cut off from any light source, maintaining only the heat left over from its formation or internal processes. In such conditions, it would be a world of perpetual night, with no seasons, no day, no night. Just an endless, cold expanse. These are places where our imagination struggles to keep up with reality, where the rules we understand might break down in ways we don't yet comprehend. There's a deeply human aspect to the pursuit of these distant planets, like MOA 2012, BLG 505. We may never visit them, but our curiosity pushes us to know more, to stretch the limits of our technology and understanding. The discovery of this planet is part of a larger story of exploration, one that spans not just physical distances but intellectual ones. We've come from thinking our solar system was the entire universe to realizing we are just one tiny part of a galaxy filled with countless planetary systems, each as unique and mysterious as the last. Every new planet we discover forces us to redefine what we think is possible, to adjust our models of planetary formation, and to think about what kinds of life, or non-life, could exist in these far-off places. MOA 2012, BLG 505 is a reminder that the universe is both knowable and unknowable at the same time. We have the tools to detect planets that lie beyond our immediate reach, yet these detections only offer us the briefest of glimpses. They open up more questions than answers, inviting us to think about worlds where the conditions are so foreign, they seem more like science fiction than reality. And yet, they are real, existing right now, orbiting their stars or drifting through space, completely indifferent to whether we know about them or not. This is the universe we live in, an endlessly complex, beautifully chaotic expanse that never ceases to surprise us. OGLE 2007, BLG 349 is one of those cosmic finds that strikes at the heart of our curiosity about the universe, a world discovered not by the usual methods but through gravitational microlensing. Imagine the quiet grandeur of a planet hidden in the dark recesses of space, only detectable when its gravity momentarily alters the light from a distant star behind it. For that brief moment, the alignment of stars, planets, and gravity tells us there's something there, an object we might never see, but whose presence is undeniable. What truly makes OGLE 2007, BLG 349 so fascinating is the complexity of its discovery. This planet, along with its host star, orbits within a binary star system. Two stars, locked in a cosmic dance, host this planet between them. Binary systems are not uncommon, but finding planets in such systems complicates our understanding of planetary formation. The gravitational forces between two stars are complex, and for a planet to remain stable within such a system means it has to navigate a delicate balance, a cosmic tightrope act. This immediately raises questions about how such a planet could have formed in the first place, and what kind of environment it experiences in the dual gravitational pull of its two suns. Thinking about this planet's potential environment is where the mind starts to reel. Binary star systems can create dynamic climates and lighting conditions that we can only speculate about. Imagine standing on the surface of OGLE 2007, BLG 349, looking up at the sky to see not one, but two suns. Depending on the planet's orbit, the two stars might rise and set at different times, creating a sky that alternates between two different sources of light, or they could shine simultaneously, bathing the planet in a strange, overlapping glow. The concept feels almost otherworldly, as if plucked from the realm of science fiction, yet it is real. The existence of this planet in such a system also forces us to rethink the dynamics of planetary stability. Binary star systems introduce complexities in terms of gravity, temperature, and orbital resonance. A planet like OGLE 2007 BLG 349 could experience extreme shifts in climate, depending on the distance of its orbit from the two stars. If it's too close, the planet might be scorched by radiation. Too far, and it could freeze in the cold void between its suns. These extremes force us to imagine environments that stretch beyond anything we know on Earth. What if the planet experiences wildly different seasons depending on how the stars move in relation to each other? Or what if its climate remains relatively stable despite the dual sun configuration, defying our expectations? The discovery of OGLE 2007 BLG 349 feels like unlocking a door to a new way of thinking about how planetary systems can form and evolve. It's a piece of a much larger puzzle, one where planets are not just locked in orbits around single stars but can exist in more complex arrangements, adding layers of diversity to the types of worlds that might exist in our galaxy. And it doesn't stop at just two stars. Who knows what other kinds of systems might host planets? Triple star systems? More? Each new discovery like this one challenges our previous assumptions and pushes the boundaries of what we think is possible. There's a deep human element to the excitement of finding planets like OGLE 2007 BLG 349. It's not just about the science. It's about the way it forces us to imagine life beyond Earth in settings that are far stranger than we could have ever dreamed. If we ever discover life on planets and binary systems, how would it evolve under the light of two suns? How would the passage of time feel on a planet where the sky is lit by two sources, perhaps alternating between a warm golden light and a pale white glow? These questions stir something fundamental within us, a desire to explore not just physically, but intellectually, expanding the limits of our understanding of life and the universe. At the heart of it all, OGLE 2007 BLG 349 is a reminder that the universe rarely conforms to our expectations. Every time we think we've got a handle on how planets form or where they can exist, we find something new, something that shows us the universe is far more creative than we are. And that's perhaps the most mind-boggling thing about it. The realization that we are constantly learning, constantly redefining what we know, and that the universe, in its infinite complexity, will always keep us guessing. MOA 2013 BLG 220 is one of those planetary discoveries that feels like a glimpse into the hidden mechanics of the universe, a reminder of how much is happening beyond the reach of our daily lives. Its discovery through microlensing means that this planet revealed itself to us for only a fleeting moment, when its gravity bent the light from a distant star just enough for us to catch a hint of its existence. There's something deeply poetic about that. A planet existing in the darkness of space, momentarily aligning in such a way that we, on Earth, could detect it from incomprehensible distances away. What makes this particular planet so fascinating is the method through which we discover it. Microlensing is a phenomenon that requires incredible precision. The gravitational fields of objects, like stars and planets, must align perfectly with a background light source from a distant star. It's a blink and you miss it kind of event, a cosmic coincidence that gives us the opportunity to know that something is out there. And what we know about MOA 2013 BLG 220 suggests that this world is likely a massive planet, perhaps a gas giant, sitting far from its host star in a cold, distant orbit that makes it nearly invisible in the regular light of space. The discovery of planets like MOA 2013 BLG 220 forces us to reconsider our ideas about where and how planets can exist. It could be orbiting a star that's vastly different from our sun, perhaps a faint, cool star that gives off barely any heat or light. Or the planet could be a rogue, drifting between stars with no true home, just floating through the galaxy in the endless blackness. Either possibility stretches our understanding of planetary systems and how they form. These worlds might form in environments so different from our solar system that we can't begin to guess what they're like on the surface, if they even have a surface at all. One of the most mind-boggling aspects of planets like MOA 2013 BLG 220 is the sheer number of them that must exist. If we're able to detect planets through such rare events as microlensing, it means that the universe must be filled with countless worlds, most of which will never cross our radar. Every time we catch one of these planets in the act of bending light, we're reminded of how much we can't see, how much is out there, hidden in the folds of space. It's a humbling thought that the universe is teeming with planets like MOA 2013 BLG 220, silently orbiting their stars or drifting through space, with no sign of their existence until the perfect alignment happens. But what truly grips the imagination is thinking about the nature of these distant planets. A massive gas giant sitting far from its star might have a thick, swirling atmosphere of gases that we can't even fully understand, gases that would freeze in our solar system but remain in a strange, suspended state in the cold outer regions of MOA 2013 BLG 220's orbit. Or maybe this planet has moons, small worlds orbiting it, each with its own unique characteristics, locked in an eternal, frozen dance around their parent planet. The possibilities are endless, and that's what makes these discoveries so captivating. They make us dream about what could be, even when we have so little information to go on. For humans, discovering planets like MOA 2013 BLG 220 is more than just a scientific achievement. It taps into our deep, almost instinctual desire to explore, to push beyond the boundaries of what we know. Each of these planets is a reminder that the universe is so much more than what we can see from Earth, and it drives us to keep searching, to keep wondering. Even though we may never visit these planets, may never even get more than a few faint data points about them, the act of discovering them is an affirmation that the cosmos is vast and mysterious, and that we are just beginning to scratch the surface of what's out there. Every new discovery, like MOA 2013 BLG 220, is a nudge to keep looking up, to keep imagining what could be hiding in the farthest reaches of space, waiting for its moment to briefly reveal itself. KMT 2016 BLG 1820 is one of those cosmic discoveries that stretches the imagination. It was discovered through a method called gravitational microlensing, a technique where astronomers observe the bending of light from a distant star caused by the gravitational field of a massive object passing in front of it. The object itself isn't directly visible, but its existence is confirmed by the way it warps space-time, almost like a silent cosmic fingerprint left behind. This particular discovery involves a planetary system. KMT 2016 BLG 1820 points to a planet orbiting a low-mass star, or possibly a brown dwarf, an almost star that doesn't have enough mass to ignite nuclear fusion in its core. What makes this system fascinating is how it pushes the boundaries of our understanding of planetary formation. The planet in this system orbits its star at a vast distance, much farther than where you typically expect to find planets in traditional planetary systems. It challenges the standard model of planet formation, which assumes that planets form in a circumstellar disk close to their star and migrate outward. Here, we have a world that might have formed in a cold, distant region, almost on the fringes of its star's influence, where the gas and dust needed for planetary formation are sparse. It's a strange, almost isolated existence for a planet. It makes you wonder what the surface of this planet might be like. Orbiting a faint star so far from the heat of a stellar furnace, it's likely to be a frozen wasteland, with temperatures that plummet to unimaginable lows. It's a world where darkness rules, a place so cold that even the gases we know as atmospheres might freeze into solid ground. Yet, it's orbiting something that could technically be called a star, albeit a dim one. The human fascination with extreme environments extends here because it makes us think about the limits of what is possible. Could such a planet hold life? The chances seem slim, but then again, nature has surprised us before, whether it's extremophiles thriving in Earth's most hostile environments or discoveries of strange moons and planets breaking the molds of how we think worlds should behave. KMT 2016 BLG 1820 is also a testament to how we are just scratching the surface in terms of discovering planets beyond our solar system. It's fascinating to think about how many more are out there, orbiting quietly in the vastness of space, unseen and unknown. Every new discovery like this one broadens our sense of what kinds of planetary systems exist. Some of these systems seem to defy logic, with planets orbiting dead stars, or in this case, a distant, low-mass star or brown dwarf that barely glows. It's humbling in a way that these planetary systems challenge our theories, remind us of how little we know, and force us to ask deeper questions about how our own solar system fits into the cosmic landscape. There's a beauty in that unknowing, in that quest to seek answers in places so far removed from us that they might as well belong to another realm of reality. What makes this even more intriguing is the fact that this planet was found using gravitational microlensing, an incredibly precise method that requires multiple points of observation and international collaboration. This discovery wasn't made by one person or even one team. It involved a global network of scientists, telescopes, and data analyses. It's an example of how interconnected our efforts to explore the cosmos have become. We may never visit KMT 2016, BLG 1820, but through the power of technology and collective human effort, we've pulled back the curtain on another piece of the universe. It feels like a glimpse into a realm that operates on scales so massive, so beyond our everyday experience, yet is also driven by the same forces of gravity and physics that shape our own world. In a very human sense, discoveries like these make you wonder about the vastness of space and our small but persistent desire to make sense of it. We're creatures bound to one planet, yet we have this deep need to map out everything beyond it. KMT 2016, BLG 1820 is just another pinprick of light in the infinite dark, but for us, each one of these points represents a possible future, a deeper understanding of where we come from, and perhaps even where we might go. It's a mystery box of potential. What kind of worlds, what kinds of systems exist out there that we have yet to discover? And each discovery, no matter how cold, distant, or seemingly uninhabitable, brings us closer to grasping the bigger picture. OGLE 2016, BLG 1195 is one of those celestial finds that subtly reshapes our understanding of the universe. Discovered through microlensing, this object turned out to be a planet orbiting an incredibly faint and distant star, or perhaps even a brown dwarf or rogue planet. It sits far, far away from its host star, which barely emits any light. In the vast darkness of space, this planet exists in what can only be described as a kind of cold isolation. What immediately makes you think twice about this discovery is the fact that this planet orbits in the galactic bulge of the Milky Way, an area teeming with stars, cosmic dust, and ancient stellar remnants, a chaotic and dense region where life as we know it would find it almost impossible to emerge. The planet itself is intriguing because it is around the size of Earth. But unlike our world, this planet orbits so far from its star that it's likely frozen solid, with temperatures plummeting to levels we can barely comprehend. Imagine a world where the warmth of a star never really reaches you, where the day never brightens and night never truly ends. There's something haunting about that. A planet similar to Earth in size but existing in a state of eternal freeze, far removed from the dynamic systems that make Earth so vibrant and alive. It forces you to consider how lucky Earth is in its position around the Sun, sitting comfortably in the habitable zone where liquid water and life can flourish. This discovery also raises profound questions about how planets like this can form in such cold, distant regions. Traditional models of planet formation tell us that planets form within protoplanetary disks close to their stars, but OGLE 2016, BLG 1195 defies that logic. It's a reminder that there are no hard and fast rules in the cosmos. Just when we think we've nailed down how planets are supposed to form and behave, we find outliers like this one that force us to rethink those models. Maybe planets can form at the extreme edges of a solar system, far beyond where we'd expect, or maybe this one was ejected from a more favorable zone and cast out into the cold. Either way, it's a strange, solitary existence. What makes this system even more curious is the nature of the star or object it orbits. Some think it may not even be a star at all, but rather a brown dwarf, a failed star that never got hot enough to sustain nuclear fusion, the process that powers stars. Brown dwarfs are strange in their own right, sitting between planets and stars, occupying a murky category in the celestial hierarchy. If OGLE 2016 BLG 1195's host is indeed a brown dwarf, then this planet is essentially orbiting a near star, a dim, ghost-like object that in itself is compelling. Imagine a planet orbiting a star that never fully lit up, a system where the usual rules of starlight and heat don't apply. It's a kind of cosmic dead end, yet it exists. Then there's the sheer distance. OGLE 2016 BLG 1195 is situated in a region of the galaxy that's incredibly far from Earth, and its discovery relied on incredibly delicate measurements of light bending around an invisible object. The fact that we can detect planets so far away using these advanced techniques is a testament to how far human curiosity has pushed our technological limits. The planet itself, though likely inhospitable, feels like a symbol of how much more is out there waiting to be found. What other strange and lonely worlds are out there, orbiting the quiet remnants of stars or drifting through the galaxy with no star at all? This discovery taps into a very human fascination with the unknown. OGLE 2016 BLG 1195 is a distant, frozen planet that will never experience the warmth of a sun. A world that couldn't be more different from Earth, yet it exists. It's as though the universe is reminding us that it holds countless mysteries, many of which are far beyond the boundaries of what we thought possible. In a way, it's humbling to think that while we're here, basking in the light of our sun, there are planets like this one, dark and frozen, quietly orbiting their faint, distant stars in the galactic wilderness. Each one reminds us of the unimaginable diversity of the universe and how little we've seen, how much more we have to explore. In some ways, discoveries like OGLE 2016 BLG 1195 make the cosmos feel both immense and intimate. It's immense in the sense that these planets are so far removed from our day-to-day experience that they seem almost unreal, but intimate in the sense that each discovery is a direct result of human effort, of our desire to know what's out there. Despite its remoteness, this frozen world has a place in our understanding of the galaxy, and each time we discover a planet like this, we add another piece to the puzzle of what makes the universe tick. There's a strange beauty in that, in knowing that even the coldest, most distant planets contribute to the larger story we're trying to tell about the cosmos and our place in it. MOA 2009 BLG 387 is one of those planets that makes you question how diverse the universe can be. This exoplanet, found using gravitational microlensing, orbits a star so distant and faint that we wouldn't have been able to detect it through any other means. It's located about 20,000 light-years away, deep within the galactic bulge, a place where stars are packed together in a dense cluster near the center of the Milky Way. The sheer distance involved here is staggering. To put it in perspective, this planet is orbiting its star in a region that we can barely see with our most powerful telescopes. Yet here we are, mapping out planets that lie almost on the other side of our galaxy. That in itself is mind-boggling. How the faintest gravitational tugs from a tiny speck of matter can be detected across such enormous distances. It's like hearing a whisper from across a football field in the middle of a thunderstorm. The planet itself is intriguing, primarily because of its mass and the distance from its host star. MOA 2009 BLG 387b is estimated to be about the same mass as Neptune, a gas giant floating in the outer regions of its star's gravitational pull, far removed from the warmth of the central star. It orbits at a distance so vast that it's more comparable to the icy realms of our solar system, like where Pluto resides, than the familiar orbits of inner planets like Earth or Mars. Out there, sunlight is but a distant glow, and temperatures drop to extremes that are difficult for us to grasp. Imagine a world where gas doesn't swirl in the dynamic patterns of Jupiter's storms or Saturn's rings, but instead exists in a frozen, suspended state, a quiet and cold giant on the edge of a solar system. But the more you think about it, the more it forces you to consider the limits of habitability. We tend to think of planets that are either close to their stars, bathing in warmth, or frozen solid in deep space. MOA 2009 BLG 387b sits at the far end of that spectrum, far enough away that any ideas we have about life, at least life as we know it, are hard to imagine here. Yet, it expands the definition of what planetary systems can look like. It makes you think, if planets can form in such cold, distant parts of their system, are there forms of life that could somehow survive there? Could these far-off gas giants host moons with oceans beneath thick ice, as we theorize about Europa or Enceladus in our own solar system? We don't know, but the possibility is haunting. What adds an extra layer to this discovery is that the planet's star could be a low-mass dwarf or even a failed brown dwarf, barely putting out any light or heat at all. In that case, this gas giant is orbiting something that is only technically a star by definition, a failed attempt at stellar ignition. In essence, this planet could be drifting around a ghost of a star in the cold and near darkness, a system that never quite lived up to what we traditionally think of as a solar system. It's a little melancholic, imagining a world orbiting a failed star, never feeling the full force of the light that ignites most planets into activity. The process of discovering this planet is another part of its intrigue. Using microlensing, scientists had to wait for just the right moment. when the gravitational forces of this far-off system lined up with a background star, to even notice the planet's existence. This method is so delicate, so dependent on precision, that it feels like we are hunting for cosmic ghosts, planets that flicker into view for just a moment and then disappear again as the universe shifts and moves. It's not like the way we discover planets through transit or Doppler shifts, which rely on repetitive patterns. With microlensing, you often get only one chance to observe the telltale bending of light that signals a planet's presence. It feels more like catching a rare glimpse, a fleeting acknowledgement from the cosmos that something extraordinary is out there. MOA 2009 BLG 387 is one of those planets that expands our sense of wonder. It reminds us that the universe isn't just full of Earth-like worlds or blazing suns. It's also home to these strange, distant giants orbiting in the quiet outskirts of their star systems, far removed from the action and heat. These planets exist in realms where light barely reaches, where the rules of planetary formation and survival seem stretched to their limits. It's like a reminder that the cosmos is far stranger than we often allow ourselves to believe. We tend to focus on what's familiar, the stars we see, the planets that resemble ours. But it's places like MOA 2009 BLG 387 that force us to rethink the boundaries of what's possible. What makes this discovery even more fascinating on a human level is that it represents a collective achievement. No one person discovered this planet. It was the product of a global collaboration, with telescopes across the world coordinating to capture this moment of light bending. In a way, it feels poetic that to discover such a lonely, distant planet, humanity had to come together, combining our efforts and technology to reach out into the depths of space. It's as if, through the search for these isolated worlds, we find a connection with each other, pushing the boundaries of what we can achieve together, even as the universe reveals itself to be far more complex and strange than we ever expected. KMT 2021 BLG 1077 is another example of how the universe constantly defies our expectations, revealing things that challenge what we think we know about planetary systems. This exoplanet was discovered using the microlensing technique, where scientists watch for the subtle bending of light caused by an unseen object's gravitational field. In this case, the object is a planet orbiting a distant star, far removed from any chance of direct observation. The discovery feels like finding a needle in a cosmic haystack, a rare alignment of the planet, its star, and Earth's perspective that allowed us to detect its presence for just a brief moment. That kind of precision is mind-boggling in itself, but what really grabs your attention is what this system suggests about the wild diversity of planets out there. KMT 2021 BLG 1077 is interesting because of its size and location. It's a massive gas giant, likely comparable to Jupiter, orbiting a star that is much smaller and dimmer than our Sun. This combination, the sheer size of the planet compared to the faintness of the star, makes you wonder how a planet like this could even form. It's a question that keeps surfacing with these microlensing discoveries. How do such enormous planets end up orbiting stars that barely shine? Traditionally, we think of massive planets forming in the presence of abundant material, close to a bright star with a large protoplanetary disk. But here, you've got this colossal gas giant orbiting what could be a low-mass dwarf star, or even something as dim as a brown dwarf, where there's less material and energy to work with. It defies our understanding of planetary formation, as though the universe is telling us that the rules are far more flexible than we ever imagined. The distance between this gas giant and its faint star is another puzzle. It's located far out, in a region of space where light and heat from the star barely reach. You're left picturing a massive planet in an eternal twilight, orbiting at a distance where the star is just a distant speck of light in the sky. It would be unimaginably cold out there, with temperatures so low that any familiar form of weather or atmosphere would behave in ways we can't fully comprehend. The gas that makes up this planet might not swirl in the vibrant storms we associate with Jupiter or Saturn, but could be frozen into something far more static, a quiet, desolate giant drifting in the outskirts of its solar system. That thought alone opens up new possibilities for how planets evolve in environments that are so radically different from anything we've seen in our own neighborhood. What makes KMT 2021 BLG 1077 particularly fascinating is that it seems to exist in a system where traditional planetary models don't quite apply. Planets like this one shouldn't be able to form in such distant, cold regions with such faint stars, And yet here it is. We've learned that planetary systems can be remarkably diverse, but this kind of discovery stretches those boundaries even further. It suggests that planets are capable of forming and existing in places that seem entirely inhospitable by our standards. The fact that a massive gas giant can thrive around a faint, distant star makes you rethink the sheer variety of planetary systems that must be out there, beyond the few we've been able to study in detail. It's a reminder that while our models of star and planet formation are useful, they are far from complete. There's also something poetic about how we detect these planets. Microlensing events are rare and fleeting, and when one occurs, the universe gives us just a glimpse of these hidden worlds before they vanish again, beyond the reach of our instruments. It feels a little like we're eavesdropping on the universe, catching these brief moments where the alignment of stars allows us to peer into the distant, unseen corners of space. 4KMT 2021 BLG 1077. That glimpse tells us there's much more happening out there than we ever thought possible. It's like getting a postcard from a place we can never visit, but knowing that it exists somehow changes our perception of the cosmos. In many ways, the discovery of KMT 2021 BLG 1077 speaks to the resilience and curiosity of human endeavor. We build these massive networks of telescopes and collaborate across continents to detect these subtle shifts in light, working together to uncover planets that are billions of miles away, planets that most people will never hear about, but which fundamentally change our understanding of the universe. This planet is a testament to the idea that there's still so much out there waiting to be discovered, that the universe holds countless secrets we haven't even begun to unlock. And each time we find a planet like KMT 2021 BLG 1077, it reminds us of the strangeness, the vastness, and the mystery of the universe we're trying to understand. OGLE 2015 BLG 0051 is one of those discoveries that pushes our understanding of what's possible when it comes to planetary formation. It's an exoplanet that was found orbiting a low-mass star or brown dwarf, which makes it immediately stand out. Brown dwarfs are fascinating because they're like the universe's failed stars, objects that never gathered enough mass to ignite nuclear fusion in their cores. They're too massive to be planets, but not massive enough to be proper stars. So, the fact that a planet is orbiting one of these objects is already strange, because it blurs the line between star systems and planet-like systems. This planet is orbiting something that almost became a star but didn't, and that creates a kind of cosmic limbo, where the usual rules of stellar and planetary formation don't seem to apply as rigidly as we might expect. The planet itself is about half the mass of Jupiter, meaning it's a gas giant, but orbiting something far less bright and powerful than the Sun. The conditions out there must be extreme. Imagine a world that size, but instead of being bathed in sunlight like Jupiter, it sits in the faint glow of a star that barely shines, likely in near total darkness most of the time. The cold would be unimaginable, a frozen gas giant locked in orbit around an object that never fully ignited. If there's an atmosphere, it's probably a calm, frigid layer of gases trapped in a kind of stasis by the lack of energy coming from the brown dwarf. It's easy to picture this planet as a sleeping giant drifting through space, with no dramatic storms or weather like we see on Jupiter, just an eerie stillness under an eternally dim sky. What's even more fascinating is how this planet may have formed. Typically, we think of planets forming in the dense, warm regions of a protoplanetary disk around a young, energetic star. But here we have a planet forming around a brown dwarf, an object that lacks the same level of energy to shape its surroundings in the way a normal star does. This raises questions about how much material was present around the brown dwarf during its formation, and how it managed to pull together enough gas and dust to form a planet this large. It challenges the idea that strong, bright stars are necessary for massive planets to come into being. Somehow, in this distant system, conditions align to create a world that shouldn't, by standard models, be there. It's a reminder that the universe has a way of doing things that don't always fit neatly into our theories. The distance from Earth makes this discovery even more awe-inspiring. It's located about 13,000 light-years away, deep within the dense and crowded regions of the Milky Way known as the galactic bulge. This area is filled with stars, old and new, remnants of ancient supernovae, and a swirling mass of cosmic material. To detect a planet there, among so much stellar chaos, is impressive. The galactic bulge is not the kind of place we usually think of as having calm, stable environments where planets can thrive, so it's surprising to find a planet orbiting a star, or almost star, there. The fact that we can detect such planets in these far-off, complicated regions of space shows just how advanced our techniques have become. We're reaching farther and deeper into the galaxy than ever before, pulling new kinds of planetary systems into view that were previously unimaginable. On a more human level, this discovery taps into our need to explore the unfamiliar. It's not just about finding planets that could support life or are Earth-like. It's about understanding how diverse the universe really is. OGLE 2015 BLG 0051 gives us a glimpse into a kind of planetary system that's far removed from anything we're used to. Planets orbiting dim, failed stars in regions of the galaxy that are chaotic and dense. It forces us to consider that the universe isn't just made of neat, orderly systems like our own solar system, but is also filled with these strange, mismatched, and unexpected worlds. There's something deeply exciting about that, knowing that each time we find a planet like this, it's expanding the boundaries of what we thought possible. What's particularly striking is the method through which it was discovered. Microlensing, the technique used to detect this planet, relies on the alignment of stars, requiring the foreground object's gravity to bend the light from a more distant star. This method is like listening for faint echoes in a noisy room. It's difficult, fleeting, and requires incredible precision. The fact that we can use this technique to find planets orbiting objects as faint as brown dwarfs is a testament to how far our ability to probe the universe has come. It feels as though we're learning to hear the quietest whispers of the cosmos, piecing together stories about planetary systems that are otherwise invisible to us. Ultimately, OGLE 2015 BLG 0051 is one of those discoveries that makes you realize just how little we've scratched the surface when it comes to understanding the universe. It's a reminder that planets can form in the most unexpected places, that stars don't have to be bright for planets to exist, and that the universe is far more flexible and strange than we often give it credit for. And in that sense, it feels like every new discovery is a step toward understanding just how complex and varied the universe is. This planet is a small, distant, and frozen world, orbiting a dim star-like object in one of the most chaotic regions of the galaxy, and yet it exists. That simple fact opens up so many possibilities for what else might be out there, waiting to be found. MOA 2007 BLG 192 is one of those discoveries that stretches the boundaries of what we thought possible for planet formation and survival. It's a planet that challenges everything we know about the relationship between stars and their planets. The star it orbits isn't even a typical star. It's a brown dwarf, an object that sits in a gray area between a planet and a star. Brown dwarfs don't have enough mass to sustain nuclear fusion, the process that makes stars shine. They're failed stars, not bright enough to light up their systems, yet still managing to hold onto planetary companions. The fact that a planet as small as MOA 2007 BLG 192 exists around a star that's barely a star at all defies the traditional models of planet formation. How does a planet form and stick around a host that's barely putting out any energy? The planet itself is incredibly small, about 3 times the mass of Earth. This makes it one of the smallest exoplanets ever discovered around such a faint and low-mass object. It's a rocky world, much like Earth, but that's where the similarities end. This planet orbits in the cold, dim outskirts of its system, far from any significant warmth or light. Imagine a world where the concept of day and night doesn't really apply because there's almost no light to distinguish one from the other. The surface would be frozen, utterly alien to anything we know. If there's an atmosphere, it's likely thin and inert, locked in an eternal chill with little chance for the dynamic systems we associate with Earth or other rocky planets in our solar system. This is a world suspended in a kind of cosmic twilight, cold and silent, orbiting a failed star. What's really mind-bending is that MOA 2007 BLG 192 represents a type of planet we never expected to find. When we first started looking for exoplanets, the idea was that planets would form around stars with enough mass and energy to create the necessary conditions in the protoplanetary disk. But this discovery flips that script. It shows that planets can form around even the faintest, smallest stars, or star-like objects. The planet's existence suggests that planet formation is more resilient than we thought. It can happen in environments where, based on all our prior knowledge, it shouldn't. This tells us that planetary formation is more universal, more capable of happening in unlikely conditions than we previously assumed. It hints at the idea that planets could be far more common in the universe than we ever dared to imagine. Another fascinating aspect of this discovery is the distance at which it lies from us. About 3,000 light-years, located toward the center of the galaxy. This region, known as the galactic bulge, is densely packed with stars, many of them ancient and unstable. To find a planet in this chaotic area is a testament to the strange, unpredictable nature of the galaxy. We usually think of planetary systems forming in quieter, more stable parts of the galaxy like our solar system, but MOA 2007 BLG 192LB exists in a much more volatile region. The galactic bulge is an area rich in history, where the oldest stars in our galaxy were born, where supernovae have exploded, and where material is constantly swirling and interacting. It's not the sort of place we associate with the calm, long-lasting orbits that allow planets to form and survive. And yet here it is, this small, cold world orbiting a faint star in the middle of all that cosmic turbulence. What makes this discovery even more compelling is the method used to detect it, gravitational microlensing. This technique depends on the alignment of distant stars and the bending of light due to gravity. It's a fleeting, rare event where for just a moment, the universe allows us to catch a glimpse of something that would otherwise be invisible. It's almost like the universe opening a small window for us to peer through, showing us something that doesn't last long but changes our perspective forever. The precision required to detect a planet as small as this, around a star as faint as this, is mind-boggling in itself. It's like hearing a whisper across a canyon during a storm. Such a delicate signal from so far away, and yet our technology and collective effort have made it possible. There's something deeply human about this kind of discovery too. The fact that we're finding planets around these dim, failed stars speaks to our relentless curiosity and drive to explore. We're not just looking for Earth-like planets anymore. We're trying to understand all the possible ways planets can exist. MOA 2007 BLG 192LB is a reminder that the universe is full of surprises, that there are worlds out there we haven't even begun to imagine. It also highlights the fragile nature of planetary existence. If the planet had formed slightly differently, or if the brown dwarf had been just a little more massive, things might have turned out very differently. This discovery makes us rethink what is necessary for a planet to exist and thrive, and it opens the door to the possibility that planets could be more abundant and more varied than we've ever thought. When you consider the scale and distance involved, and the faintness of the objects involved, it's incredible to think that we can even detect such planets. But beyond the technology and science, there's a sense of wonder that comes with these discoveries. MOA 2007 BLG 192LB is a reminder of how little we know, of how the universe continues to reveal its secrets in ways that challenge our understanding and force us to keep expanding our sense of what's possible. It's a lonely planet orbiting a dim, failed star in the distant galactic bulge, but its discovery connects us to the larger story of the universe, one of constant exploration, curiosity, and the pursuit of knowledge, no matter how far or faint the object might be. KMT 2021 BLG 1127 is one of those discoveries that forces you to rethink the boundaries of what's out there. What we're looking at is a planetary system where a massive planet orbits a star so faint and far away that it would barely register to the naked eye, even if we could somehow observe it up close. The star it orbits is either a small dwarf star or, potentially, even a brown dwarf, an object too low in mass to shine brightly like the stars we're familiar with. Yet, even in these dim environments, planets can form, and KMT 2021 BLG 1127 shows us exactly that. The planet in this system is a gas giant, likely on the scale of Jupiter or even larger, but it exists in an environment where the rules we apply to our solar system seem out of place. It's hard to imagine a planet of this size forming around a star that provides so little warmth and light. Yet here it is, orbiting quietly in the cold, distant reaches of space. These massive gas giants are thought to need abundant material to form: gases, dust, and the heat of a young star. But KMT 2021 BLG 1127 seems to throw that assumption out the window. How does such a large planet accumulate so much mass in such a barren region of its star system? It's a question that opens up new possibilities about planet formation, suggesting that even in the cold, faint reaches of space, planets can emerge, defying what we think we know about how planetary systems evolve. What makes this even more puzzling is the distance between the planet and its star. The planet orbits far away from the central star, likely several times the distance between Earth and the Sun. At that distance, the star would appear like a dim point of light in the sky, providing almost no warmth or energy to the planet. Imagine a world where the concept of a sun barely exists. There's no day and night cycle like we have here on Earth because the star doesn't shine brightly enough to mark time in the same way. Instead, the planet likely exists in a perpetual state of darkness or twilight, cold and frozen in the far reaches of its system, with only the faintest glow from its distant star. It's almost as though this planet is a ghost, drifting through space in an environment so alien and distant that it feels untouchable. Then there's the method by which this planet was found. Like many other planets detected through microlensing, KMT 2021, BLG 1127 was discovered due to a brief, precise alignment of stars. When the gravity of a massive object, like the planet and its star, bends the light from a more distant star behind it. This microlensing event is fleeting, lasting only a short time, and if we miss it, that planet slips back into obscurity, hidden from us forever. What's so incredible about this is that we're essentially catching a momentary glimpse of a planetary system that exists far beyond our direct observational reach. These planets, orbiting faint stars in distant parts of the galaxy, would otherwise remain invisible to us without this brief alignment. It feels like the universe is giving us tiny, rare windows through which we can glimpse these far-flung worlds. KMT 2021, BLG 1127's discovery raises another interesting point about the diversity of planetary systems. For a long time, we assumed that most planets would form in systems that resemble our own, with a bright star at the center, rocky inner planets, and gas giants farther out. But this system breaks that mold. You've got a massive gas giant orbiting what's likely a small, faint star, in a place that seems inhospitable to planet formation as we understand it. This challenges our models of how planets form and survive in these cold, dark environments. It also leads to the intriguing question of whether planets like this one are more common than we think. Are there entire populations of gas giants and smaller rocky worlds orbiting faint stars or brown dwarfs, hidden away in the cold corners of the galaxy? Beyond the scientific aspects, there's something profoundly human in the way we approach these discoveries. The fact that we've developed techniques like microlensing to detect planets so far away, around stars that emit so little light, speaks to our relentless drive to explore. These planets don't make headlines like the ones that might be habitable or have Earth-like qualities, but they matter because they show us just how varied and complex the universe is. We are learning that the rules we thought applied universally to star systems don't always hold up. KMT 2021, BLG 1127 represents a part of that learning process. This cold, distant planet orbiting a faint star tells us that there's so much more out there to discover, so many more ways that the universe can surprise us. It's easy to think of this planet as a lonely, frozen giant wandering through the outskirts of its solar system, but in reality, it's part of a much larger cosmic story. Every time we discover a planet like this, we push the boundaries of our understanding, not just of planets and stars, but of the universe itself. KMT 2021, BLG 1127 is a testament to the fact that even in the most unlikely places, even in the coldest, darkest corners of space, there's still more to find. It's a reminder that the universe is far stranger and more diverse than we often give it credit for, and that with each new discovery, we're just scratching the surface of what's really out there. OGLE 2013 BLG 0911 is one of those exoplanet discoveries that feels like it was plucked out of the quiet, hidden corners of the cosmos. What's remarkable about it is the sheer distance and the faintness of the star it orbits. This system, which lies thousands of light years away in the dense regions of the galactic bulge, is part of a story that we're still trying to piece together. How planets form and survive in environments so different from our own. The star at the center of this system is likely a low-mass star, possibly even on the edge of being a brown dwarf, an object that straddles the line between being a star and something else entirely. In these dark, cold regions, where there's barely enough energy to even ignite nuclear fusion, planets still find a way to exist. And not just any planets, but massive gas giants, objects that shouldn't have enough material to form so far away from energetic, bright stars. Yet here we are, with OGLE 2013 BLG 0911, staring down a planetary system that refuses to follow the rules. The planet itself is likely a gas giant, much like Jupiter, but orbiting a star that emits so little light that its day-to-day existence must be profoundly different from what we know. Imagine a gas giant, cold and distant, orbiting a faint star that barely registers in its sky. If you were somehow able to stand on the surface of one of its moons or even peer through its thick atmosphere, the light from its star would probably seem no brighter than the full moon on Earth, casting an eerie, ghostly glow over the frozen clouds. The atmosphere of the planet would be calm, with slow-moving gases suspended in a cold, heavy silence, broken only by the rare flashes of distant stars beyond its small sun. It's a world that seems locked in time, drifting through space with a tranquility that belies the chaos and uncertainty of its formation. One of the things that makes OGLE 2013 BLG 0911 stand out is how it alters our understanding of planetary formation in low-mass systems. We're used to thinking of planets forming around stars with enough heat and energy to create the necessary conditions in a protoplanetary disk. But this system suggests that even in the cold, dark reaches of space, where the light is faint and the temperatures are low, massive gas giants can still emerge. This challenges the very framework of planetary formation, pushing us to reconsider how much material is truly needed to form large planets and how much energy is required to hold a planetary system together. It's as if nature is telling us that there's no one-size-fits-all model for the universe. Planets will find a way to form, even in the most unlikely circumstances. What's also compelling is the location of this planetary system within the galaxy. It sits in the galactic bulge, a region that's densely packed with stars, remnants of supernovae, and clouds of interstellar dust. The bulge is an old part of the Milky Way, where some of the galaxy's earliest stars were born and died. It's not the calm, orderly place we imagine when we think about star formation or the development of planetary systems. Instead, it's a region of chaos, where gravity pulls on everything, where stellar collisions and interactions are far more common than in the quiet outskirts where our solar system resides. That OGLE 2013 BLG 0911 exists in such a turbulent environment only adds to its mystery. How does a planetary system survive the gravitational tug-of-war that happens in the galactic bulge? How does a planet stay in stable orbit around a faint star when there's so much chaos happening around it? The discovery of this planet also brings to light the sheer complexity and subtlety of microlensing, the technique used to find it. Microlensing events are like brief flashes, where a foreground object, like the planet and its star, bends the light from a more distant background star. These moments are fleeting, sometimes lasting only hours or days, and if missed, the planetary system remains hidden. What's amazing about this is the level of precision and patience required to catch such an event. It's like trying to catch a whisper carried on the wind in the middle of a storm. The fact that we can detect a planet so far away, orbiting such a faint star, through this tiny, ephemeral window is a testament to how far our ability to probe the cosmos has come. We're learning to see the invisible, to pull planets out of the darkness of space that would otherwise remain lost to us. Beyond the technical achievement, there's something deeply human about our drive to find planets like OGLE 2013 BLG 0911. It's not just about looking for habitable worlds or places that resemble Earth. It's about understanding the full range of what's possible in the universe. We're uncovering systems that challenge our assumptions, planets that exist in environments we didn't think could sustain them. This planet, orbiting a faint, cold star in the bustling center of our galaxy, shows us that the universe is much more flexible than we give it credit for. It's a reminder that the cosmos doesn't always adhere to the neat categories we've created. There are entire worlds, entire systems out there that don't fit our preconceptions, and that's both humbling and exciting. What's even more mind-boggling is what this discovery could mean for our search for planets elsewhere in the universe. If massive gas giants can form around faint stars in the chaotic galactic bulge, then what else is out there? Are there Earth-like planets, rocky worlds orbiting low-mass stars in regions we haven't even considered looking yet? The existence of OGLE 2013 BLG 0911 makes it clear that we've only scratched the surface of what's possible. This system is a tantalizing hint that the universe is full of surprises, full of planets that are waiting to be discovered, even in the most unlikely corners of the galaxy. It's strange to think that a planet so distant, orbiting a star so faint, could have such a profound impact on our understanding of the universe. Yet that's exactly what OGLE 2013 BLG 0911 does. It reminds us that the universe is vast, complex, and full of wonders that we're only beginning to uncover. The more we learn about distant planets like this one, the more we realize that our place in the cosmos is just one small part of a much larger, more intricate tapestry, one that's full of strange and unexpected worlds. MOA 2010 BLG 477 is one of those rare finds that stretches the boundaries of what we consider possible in the universe, particularly when it comes to planetary evolution. What makes this system so fascinating is the fact that the planet it hosts is orbiting a star that has already gone through its life cycle and evolved into a white dwarf. A white dwarf is the final evolutionary stage of a star like our Sun, a dense, hot remnant left after the outer layers have been shed in a violent process. So what we're looking at here is a planet that somehow survived the death throes of its parent star, a process that, by all accounts, should have been catastrophic for any nearby worlds. The star would have expanded into a red giant, potentially engulfing or incinerating any planets in its vicinity, and yet, here's this planet, still orbiting its now shrunken star. The idea of a planet orbiting a white dwarf opens up a flood of questions. How did this planet survive the transformation of its star? Was it always there, managing to escape destruction through sheer luck and distance? Or was it captured after the star evolved into a white dwarf, pulled into a new orbit by the intense gravity of the dying star? Either scenario is mind-boggling. If the planet did survive its star's transformation, it would have witnessed an apocalyptic event, with the star expanding hundreds of times its size, burning through the last of its nuclear fuel, and eventually shedding its outer layers into space. For a planet to endure that kind of chaos without being obliterated or thrown out of the system is incredible. And if the planet was captured later, that implies a complex gravitational dance, a delicate balance where the planet managed to settle into a stable orbit around this stellar remnant. The planet itself is likely a gas giant, something on the scale of Jupiter. It's probably cold, distant, and frozen now that its star no longer emits the same level of heat or light. Orbiting a white dwarf means this world is bathed in faint, ghostly light. No longer the warm glow it would have experienced when its star was still burning brightly. If the planet has moons, they too would be locked in this strange twilight, circling their giant host in a system that feels like a relic of what once was, a reminder of the violent life cycles stars undergo. The fact that this planet exists at all also raises profound implications for the future of our own solar system. In a few billion years, our sun will go through a similar process, expanding into a red giant before collapsing into a white dwarf. Will our gas giants, Jupiter, Saturn, still be there, orbiting a faint, shrunken sun? Could Earth, assuming it hasn't been consumed or ejected from the system, remain in some cold, distant orbit, a lifeless rock circling a white dwarf? MOA 2010 BLG 477 offers a glimpse into this distant future, showing us what might happen to planets and systems where the central star undergoes such a dramatic transformation. It's a haunting, almost eerie thought. A once vibrant system reduced to a dim, quiet existence, with planets silently orbiting a dead star. What's also fascinating is the discovery method. This planet was found using gravitational microlensing, a technique that relies on the gravitational pull of a massive object bending light from a more distant star. Microlensing events are rare and fleeting, giving us only a brief window into these distant systems. But what's particularly interesting about MOA 2010 BLG 477 is that it was one of the first examples of a planet orbiting a white dwarf to be discovered this way. It shows us that microlensing is not just a tool for finding planets around ordinary stars. It can also reveal the remnants of planetary systems long after their stars have evolved past their prime. This discovery also hints at something even more tantalizing: the possibility of other planets orbiting white dwarfs, or even entire planetary systems that have survived the death of their stars. If MOA 2010 BLG 477 can exist, What else might be out there? Are there other gas giants, or even rocky planets, circling the remnants of dead stars, hidden in the vastness of space? Could there be Earth-like planets orbiting white dwarfs, planets that once supported life but are now frozen, their atmospheres stripped away by the stellar winds and radiation of their dying stars? These are the kinds of questions that push the limits of what we know about planetary evolution and survival. What's even more profound is the implication that some planets might outlive their stars. In a universe where stars are born, live out their lives, and eventually die, the idea that planets could persist, circling the remnants of their parent stars for billions of years, is both awe-inspiring and humbling. It challenges our understanding of time on a cosmic scale. We tend to think of planets and stars as being tightly bound, but discoveries like MOA 2010 BLG 477 remind us that planets can endure long after their stars have burned out. In this case, the planet is a survivor, a testament to the resilience of planetary systems, even in the face of the most violent cosmic events. And then there's the human element in all of this. Our ability to detect such a planet, orbiting a white dwarf thousands of light years away, speaks to our insatiable curiosity about the universe. We're looking at systems that challenge our understanding of what's possible, pushing the boundaries of what we thought we could find. MOA 2010 BLG 477 is more than just a planetary system. It's a glimpse into the future, a reminder of the violent, transformative processes that govern the cosmos, and a testament to the resilience of planets in even the most extreme conditions. It's discoveries like this that keep us searching, keep us asking questions, and remind us that the universe is far more complex, far more surprising than we can ever fully comprehend. OGLE 2005 BLG 390 is one of those exoplanetary discoveries that fundamentally shifts how we imagine planets beyond our solar system. This planet orbits a faint, low-mass star, likely a red dwarf, and what makes it remarkable is the sheer isolation and extreme cold it experiences. Located about 21,000 light-years away, this planet is so far from its star that the temperatures on its surface would be unimaginably cold, estimated to be around -220 degrees Celsius. This is a world locked in a frozen existence, a far cry from the vibrant, life-filled planets we often dream of finding. Yet, there's something hauntingly beautiful about it. It represents a class of planets that we had barely considered before. Frozen, distant worlds that exist far from the warmth and energy of their host stars, where life, as we know it, couldn't possibly take hold. The planet, OGLE 2005 BLG 390lb, is roughly 5 times the mass of Earth, making it one of the smaller planets found via microlensing, a method that typically detects larger, gas giant planets. This fact alone is significant because it shows that microlensing can reveal smaller, rocky planets like those we consider Earth-like, though Earth-like in mass is about the only similarity here. It's a rocky planet, but its conditions are so extreme that it is likely more akin to a frozen wasteland. There are no oceans, no liquid water, just ice stretching across the surface, maybe with an atmosphere so thin and cold that it barely holds together. It's the kind of place that reminds us that while Earth is special, the universe doesn't necessarily build planets with life or habitability in mind. What makes this system even more intriguing is the sheer distance of the planet from its star. OGLE 2005 BLG 390lb orbits at a vast distance, much farther than any of our solar system's planets are from the Sun. The star itself, being a faint red dwarf, emits only a fraction of the light and heat we're used to. From the surface of this planet, the star would appear as little more than a dim, reddish in the sky, barely providing any light to the frozen landscape. It's as if the planet exists in a permanent twilight, with the distant star too faint to offer any warmth. This makes you wonder what it would feel like to be there, standing on a rocky outcrop of ice with nothing but the silent, frozen expanse stretching out in all directions, the universe itself feeling distant and uncaring. The discovery of OGLE 2005 BLG 390 also raises deep questions about the diversity of planetary systems. We tend to think of planets as existing within a certain habitable zone, the range where conditions could support liquid water and potentially life. But this planet shows us that planetary systems are far more varied than we imagined. It makes you ask, how many other frozen, isolated worlds are out there, orbiting faint stars in the far reaches of space, places that we might never have considered looking? The discovery of such a cold, distant planet also challenges the way we think about planet formation. It suggests that planets can form and survive in environments that are incredibly hostile, where the gravitational forces between star and planet are weak, and where the material available for planet building is sparse. What really stirs the imagination is thinking about the future of this planet. Red dwarf stars like the one it orbits burn slowly and can live for tens of billions of years, far longer than stars like our Sun. This means that even though this planet is frozen and uninhabitable now, it could remain in this system for an unimaginably long time. If there were ever the possibility for change, say, if the planet's orbit brought it closer to the star, or if something triggered geological activity deep beneath its icy surface, it could experience a transformation billions of years from now. The thought of a planet frozen for eons, only to awaken through some cosmic event, is a reminder that in space, time operates on scales we can barely comprehend. And then there's the human element. The discovery of OGLE 2005 BLG 390 required an incredible level of patience and precision. Microlensing, the method used to detect this planet, works by capturing the brief alignment of a distant star with a foreground object, like a planet, which bends the light of the background star. These events are fleeting, lasting only a short time, and if we miss the exact moment of alignment, the planet would remain hidden, its existence unknown to us. What's amazing is that we've developed the ability to detect planets like this, rocky, cold, distant, by using the subtle bending of starlight. It speaks to the lengths we will go to uncover the secrets of the universe, even when the planets we find seem so far removed from the vibrant, life-supporting environments we're most curious about. Yet, despite its extreme conditions, OGLE 2005 BLG 390LB serves as a reminder that the universe is filled with a staggering variety of worlds. Each planet tells a different story, revealing new facets of planetary formation, survival, and the nature of star systems. While we may be more drawn to planets that resemble Earth, finding worlds like this, frozen, lonely, and incredibly far away, broadens our understanding of what's out there. It challenges us to think beyond our own experiences of what makes a planet interesting or habitable and forces us to confront the vast, uncaring nature of the cosmos. This planet, in its icy stillness, reminds us that not every corner of the universe is built for life, but every corner has a story to tell. And that's a wrap on our journey through the strange and wandering world of rogue planets. I hope you enjoyed exploring these cosmic drifters as much as I did. From the curious CFB DSIR 2149-0403 to the mysteriously named OGLE 2005 BLG 390, the universe sure has a way of surprising us with its rebellious nature. Thank you so much for watching. If you're fascinated by the hidden mysteries of space and want to dive deeper, make sure to give this video a thumbs up and hit that subscribe button so you don't miss out on more cosmic adventures. Until next time, keep wandering through the stars, just like those rogue planets.